So just to be frank about it, you're going to be out here going, my boss just asked me what SQS costs, and I have no idea, right? And so what's going to happen is you're either going to come here or to calculator.aws. Let me show you this on calculator.aws. Let's say we create an estimate, and what I'm looking for is someone's asked me to set up an SQS queue because they want to do some asynchronous messaging. So if I go over here and look, let's say we're in Virginia, and let's say that I'm expecting about 100,000 queue requests, right, per month. So 100 million per month. Let's just say one. Let's say 1 million per month. Make it this is just slightly used, right? And I'm not using FIFO, which is first in, first out. And the data transfer I expect, since these messages are really, small, I'm actually expecting some kind of like intra-reason transfer because this is going to be coming from like an EC2 box or something. And so, from all other regions, I expect maybe like 2 terabytes a month. Outbound, I expect 1, maybe to, let's say Ohio, all other regions, right? You come down here and look in a queue at 1 million messages per month, plus 2 terabytes of inbound transfer and 1 terabyte of outbound transfer. It's going to cost you $20. Now, if you won't know these dimensions of pricing. You're going to have to go look at them, right? And so, without even having to go parse through the documentation, the calculator will very simply tell you exactly how you figure out costing. So whether it's calculator.aws or whether it's the simple monthly calculator, going to look at those, both of them will tell you exactly what you need to know about the dimensions of pricing. And you might not know the answers to these questions, but they will tell you what questions to go get the answers to. Right? So this is actually extremely useful for that purpose. So Calvin, I hope that's helpful. Does that answer your question about how to figure out pricing? I'm like, where's my chat?
Yes, sir. Yeah, that's what I was looking for. Thank you.
Yeah, good deal. Do you know, by the way, that when you create an account with AWS, they do start off with something called the free tier. What that means is that when you create an account with AWS, and I wish they had limits so you couldn't go beyond the free tier. People have been giving them a lot of static for that, but they haven't responded to it yet the way we want them to. Notice that you get a bunch of services for free. In other words, you can run a T2 micro or a T3 micro for free for the first year in your account. And by the way, usually what I do is I just create new accounts every year. And I do that because I run an organization and I just add a new account. So what this means is that you can actually run an RDS database at this size. So I just want to notice this, but all of this is free. It's got to be a T2 micro database, right? So just notice that for the first 12 months of your account, you get a bunch of stuff for free. After the first 12 months, some of this stuff goes away and you get like 1 million lambdas a month, right? So it's like up to 3.2 million seconds of compute time, SNS up to 1 million messages. In other words, there's a bunch of stuff here that you just get for free in perpetuity. There's some things that you need a new account for. Chime, by the way, is their GoToMeeting. I gotta tell you, not my favorite product. Moving on. So simple email service, Cognito, SQS, code build, code commit. So, if you can actually create your own stuff inside of AWS and not have to pay a dime for a lot of this stuff. This is where you end up paying like 10 cents a month because they gave you a bunch of free stuff and all you're doing is like demoing or messing around. So my recommendation is that make sure you've got a brand new account, like create a new account or create an organization with your old account and like create a new account and just put it under the account. So that way, as you add accounts, it doesn't get annoying in order for you to like provision and whatnot. So just know that when you create an AWS account, some of the stuff is free for a year, some of it is free forever. So if you want to know which stuff is only 12 months free, it's this stuff. API gateway, 30 gigabytes of elastic block storage, EFS. The Elastic Container Registry, which is something we talked about yesterday afternoon. Elasticache, which we also talked about. OpenSearch, which is basically Elasticsearch. MQ, which is a managed ActiveMQ, Recognition, Poly, these are all machine learning tools, transcribe, amplify. Anyway, there's a bunch of stuff here, stuff that we haven't really talked about. OpsWorks, that's funny. And then elastic load balancing, so you get a free load balancer per month. My recommendation, make sure that you infrastructure as code, create your infrastructure in your account if you're going to use the free tier. And then that way, when you have to recreate it in another account, you can literally just snapshot it or create an AMI and then just launch it into a new account. That way you can just keep your stuff free if you want to. Okay. Okay. Any other questions or requests this morning? All right, just making sure. Yurdy. Apparently my fingers are in the wrong spot in the keyboard. All right, so just a reminder that it's now 9:43. We started at 9:30. I am recording, by the way. So this is our last day together. What's going to happen today is that at around like 11:55, I'm going to stop because I'm going to go teach a webinar on how to learn on AWS for booze, actually. And then what happens is we're going to reconvene at 1 o'clock. We will be pretty close to done with most of our material. We'll have like maybe 1, maybe 2 hours left of lecture at that point. So around 3 o'clock, what I'll do is I'll actually talk about, right at lunch, I'm going to talk about exam certification. So we're going to do some practice exams and cover the final questions around what you're going to do after you leave this class. Then we're going to cover the remaining material after lunch. So right at 1 o'clock, we're going to do exam prep. 1:30, we're going to move on to the rest of the material. Right around 3 or 3:30, we're going to switch over to the capstone lab. I will actually officially close class at that point in time, meaning that I'm going to talk about next steps. I'm going to make sure that you have the evals, and then I'm going to let you start the capstone lab. At that point in time, you can hang with me and we'll finish out the lab, and that will be the end or the cap of the day. Or if you're like, hey, I'm absolutely done, I'm brain dead, you can leave at that point in time. That last lab does take about 2 hours, 2 to 3 hours to work through, but I'm going to make sure that you know exactly where to look to get the answers because it's in your supplemental section that's inside Skill Builder where they actually give you the step-by-step instructions. Otherwise, they don't give you step-by-step instructions and they challenge you to figure out how to build some of this infrastructure. Okay, so the capstone lab is really fun because it gives you a lot more freedom to explore and learn how to navigate. It can also be very challenging if you're like, I've never done this before. And so they give you the answers if you want to do that as well. Okay. So break around 11, lunch just before noon, resume at 1, exam practice for 30 minutes. From 1:30 to 3:30, we're going to finish out our remaining material. Around 3:30 or so, maybe 4. I keep pushing the time around because we'll see how we go. We're going to do the capstone lab, and then that'll be the end of class. Okay. Questions about any of that? Any requests to shift, change, or anything there? Okay. Pause this just for 1 minute. Sorry, there we go. All right, so here we are in our journey, and here we're talking about the next phase of networking. So this is what we're covering next. So a whole new kind of section around networking. All right, check in. Does anybody know how many VPCs their organization uses? Again, I'm always surprised that Amazon asks these questions as if somehow we're network engineers and we have oversight over everything that happens inside of our networks. So I'm always shocked that they ask questions like this. Does anyone know off the top of their head? Less than 20? Greater than 100? Yeah, that sounds right. So one thing I do know is that it varies, right? It really varies from organizations. Some people use a multi-account strategy. Some people use a multi-VPC strategy. Most people are using a mix of both, actually. It's a blend. So VPCs, by the way, are remember the networking segments, right? Those are the ones that have IP information attached to them. So it's a way of subdividing your account into different networking segments. So let's talk about this a little bit. So the business driver here is that they want to maintain independent networks that need to communicate with each other. And what if you need to connect hundreds of networks, which is not ridiculous? If you have 1,000 VPCs, how do you connect that 1,000 VPCs to each other if necessary, or at least centralize them in a hub and spoke model so you can get to shared resources or to security concerns? Like you might need to do deep packet inspection on everything that leaves the network. How do you do that, right? So, and the other problem is that what if you run all of your stuff in private subnets? How do you control the flow of traffic so that it actually flows privately and never actually goes out to the internet across Amazon's public interfaces? Because you don't want anybody having a chance of seeing that traffic because maybe that's your compliance rule. So how do you access services like S3 or Systems Manager, which is controlling your sessions, from inside AWS without having to leave the AWS's, like your private account network? I know that sounds weird, but there's a way for you to capture your traffic when you go to like S3 so that you don't have to actually go out to the internet and then hit S3 on the public side. You can actually hit S3 publicly, and we're going to talk about how to do that. So how do you secure things? How do you set up hybridized networks between your data center and Amazon's data center? How do you support all the traffic expansion? And then what can you use for DNS resolution? So a bunch of questions here about basically securing and connecting traffic. So networking. Notice here that we're talking about Route 53 on the far left-hand side, which is Amazon's DNS service. And then we've got virtual private gateways, which are used to connect off-cloud resources to on-premise resources, right? So you connect your data center back to Amazon. And then you've also got a VPC endpoint, which is used so that your servers can privately talk to public AWS services. I know this sounds strange, but in your head, look at the diagram we have here, right? You're running servers inside of availability zones, which are clusters of data centers. Those data centers are not running the services like S3. They're not running Systems Manager. Those services are actually in regional data centers that we don't have access to. So in order for you to actually get connected to those other data centers that are regional data centers that are actually running the regional services like DynamoDB and Lambda and whatnot, you're actually going out your internet gateway and you're hitting the public interface for those regional data centers that we can't see on this diagram, the ones that are housing S3, right? Now, the thing is that you know for a fact that Amazon has high-speed private interconnects between these availability zones in the region and these hidden regional data centers. How do we know that? Because that VPC endpoint that's down there at the bottom forces you to go over that private link instead of going out the internet to get to these services. So what you're doing here is you're controlling the pathing of how you're accessing these internet-based AWS services. Instead of using the internet interface, you're going and using Amazon's private interface to talk to these services. That keeps your traffic off the internet. It means you're not hopping across routers and stuff that may not be under your control or AWS's control. And instead, you're going across Amazon's infrastructure. That's what the VPC endpoints are for, is to reroute your traffic over private AWS backbones. Okay? I know I kind of went deep into that like right off the bat, but this is one of the best diagrams to just explain, hey, we're trying to solve the problem of whether I'm going publicly or I'm going privately to AWS services. And most people don't realize that S3 and all these other services that are regional services, they don't sit in the same data centers where your EC2 instances are. Now, the other part of this is this hybrid network thing, right? So on the right-hand side, I've got my regions with my VPCs and my availability zones, and I've got services running in those things. If I need to connect those virtual machines in AWS back to my data center, because I own it, because I'm the customer, you've actually got two options. You can actually use VPN connectivity, or you can use a physical wire, like a fiber wire. Well, it's not fiber, but you get the idea. You can run a wire basically from AWS data center all the way back to your actual data center. So instead of running VPN over the internet, which any of you who work for a large enterprise know what I'm talking about, you can actually run a cable. It's not cheap, by the way, but it's worth it. So we're going to talk about like various aspects of this. This is all our networking prep for today, right? The first is the concept I was literally just discussing, which is VPC endpoints. How can I talk to AWS's services without running over the public internet? Don't want to do that. For whatever reason, security-wise or otherwise, it doesn't work for me. Or what if you just don't want to basically run a NAC gateway? What if you don't want to run everything through the internet gateway? You can use what's called VPC endpoints. So without a VPC endpoint, I want you to start at the EC2 instance, follow it going up to a NAC gateway, then it goes to the internet gateway, then it hits the internet, and then it goes to DynamoDB. That's how traffic flows normally, is everything goes out the internet gateway. Notice that the EC2 instance is incredibly protected because it's in a private subnet that the internet can't even route to. And that NAC gateway will not accept inbound connections. So this is kind of the way we do things. But that EC2 instance, if it wants to talk to DynamoDB, you're going to have to pay for a NAC gateway. The internet gateway, by the way, is free. But the NAC gateway is like 10 cents an hour plus all the bandwidth that you shove across it. So if you throw a VPC endpoint in here, and what happens is that the VPC endpoint is going to basically give you another way to get to DynamoDB, but you're not going to go across the internet. So traffic's no longer going to go out to the public subnet, out to the internet gateway, out to the internet, and then hit the public interface for DynamoDB. It runs across AWS's backbone and just hits it. Now, this concept, most people don't know about, right? So, but it's a necessity if you want to avoid internet-facing traffic. Now, there are three types of possibilities here as far as like what kind of like endpoints you can have. One is that you can have, for example, a gateway endpoint and an interface endpoint. But I just want to tell you is that a gateway endpoint and an interface endpoint are pretty much the same thing. They're this. Assuming that Michael can actually. They're this. They route traffic privately. So a gateway endpoint and an interface endpoint are used explicitly so that you can get to certain services. But here's the cool thing. There's only two services in which you can use a gateway endpoint. That's S3 and DynamoDB. Every other single service inside of AWS is going to use an interface endpoint. And by the way, they will ask you a question on this if you take the certification. You're going to be like, I need to route S3 out to blah, 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 blah. And one of the answers will be, I want to use an interface endpoint. And here's the thing that's messed up. Both a gateway endpoint and an interface endpoint can route to S3 and DynamoDB. But if you use any other service other than S3 and DynamoDB, you have to use an interface endpoint because the gateway endpoints are older and the only technologies they support are S3 and DynamoDB. So I'm like, Amazon, why don't you just retire gateway endpoints then and stop confusing us? If gateway endpoints only support S3 and DynamoDB and interface endpoints also support S3, DynamoDB, plus a slew of other services, just get rid of gateway endpoints. And they're like, yeah, we got too many customers using them. I'm like, well, shut them down for the rest of us. Anyway. And then the last thing is the gateway load balancer endpoint. So you may remember that we had 4 load balancers, one of which was retired, which is the classic. And then we had application load balancers, we had network load balancers, and then we had gateway load balancers. Now, gateway load balancers are interesting because what they do is that this allows you to send traffic to this load balancer endpoint, and it's usually something that's going to do deep packet inspection or some kind of like security examination. That's what the gateway load balancer mainly does. And what it does is it's going to filter packets and then send it back to the system that sent it, right? So they distribute traffic, by the way, across multiple virtual appliances. So these are really for only gateway load balancers, which is kind of a specialized load balancer in the load balancer family. Now, not everything, by the way, is supported by the interface endpoints. So, even though the gateway endpoints are limited obviously to 2 services, and the interface endpoints do a bunch of services, they don't do all the services. So not everything that you think should be under the interface endpoint is available. It's like 25 services that the interface endpoints support. Just to restate this, gateway load balancer endpoints only support gateway load balancers. They're not connected to services. Now to see this visualized, I'm going to draw a little bit here. To see this visualized, note that, here we've got a public subnet, right? Here we got a private subnet. And what's interesting is that normally, like, we're going to be sending traffic out this way. And let's say that's because, this particular route table here for this particular public subnet doesn't have a destination for what I do if I hit S3 or DynamoDB. But this private subnet right here actually has entries for S3 and one for DynamoDB. And basically says, hey, I want you to go to this kind of like VPC endpoint right over here. I want you to go here, and I want you to go here, and I want you to route traffic directly to S3 and DynamoDB. So just note that the key is that you have an endpoint that's inside your like VPC, and you have a route to that endpoint for that traffic. Meaning if someone calls S3, go over here. Now Amazon accomplishes this obviously by looking at your traffic, because that's what routers do or can do. So it is looking at your traffic. Like, what are you trying to call? What DNS name are you trying to resolve to? You're trying to get to S3? Trying to get to DynamoDB? Good. We're going to send you over here. Now that's a gateway endpoint. Remember, that's the only thing that gateway endpoints support is S3 and DynamoDB. Now notice that this is route table based. Interface endpoints work a little different. So I'm going to clear my drawings out. Notice that interface endpoints don't work off of route tables. They actually take an IP address inside of your system range, your subnet range, right? So in this particular case, what would happen is that with an interface endpoint, you're actually going to send traffic over to Systems Manager. Now, most of this is typically handled for you, because if you're using Amazon's DNS, it's going to resolve out to your interface endpoint. Amazon's going to rewrite your local DNS resolver rules so that you automatically go to the endpoints, right? So this allows you, by the way, to use Systems Manager, and it's just going to route you across that private interface, go to the interface endpoint, so on and so forth, right? Yeah. So this is kind of like skimming the surface of how this works, but basically what it does is it sticks a NIC with an IP address inside your subnet. So got to make sure that you have plenty of space available if you're going to put 20 services in there, right? I think people liked this gateway endpoints better because there was less to manage with gateway endpoints. You just needed to change a route table than interface endpoints, but interface endpoints support more services. So that's why I think also Amazon's kind of straddling the line, is that people are using this, but I think they're trying to figure out where they're going to take the product, honestly. Now, the cool thing is that notice they've stuck a NIC inside your subnet. That technology is actually called private link, and you can actually create your own application private links between like shared accounts. Like, for example, like if you wanted to use like Databricks or some other third-party service, they could actually share a network endpoint, like an interface endpoint, with you, and that would give you a private connection over to your like service provider's network. So just know is that these network cards can actually be used for other purposes other than just you connecting to AWS services. So you've got other options here if you want to use them. So here what they're doing is they're actually connecting to a shared service provider who is sharing an application. This could be another account. This could be your account. It could be in the same account. Doesn't really matter. It just depends on how you want to approach it. Now, you can also route, by the way, from your VPN and direct connect connections, the one that has the physical wire on your data center. You can actually go straight to an interface endpoint. so that you don't have to go across the internet to get to S3. So just know that you can also just route your internal traffic and keep it internal so you don't have to run it over the internet. All right, so that was all about VPC endpoints, all about just keeping traffic private when you're trying to access S3 or DynamoDB or really any service that is supported, right? That was the main focus there. Now, the other thing you might want to do is that what if you have multiple VPCs, but you got one that has all of your shared services, like your configuration management, your CI/CD services, your like all that. Like how do you orchestrate that? What if you want to connect these networks together? What's interesting is that you can create what's called a VPC peering connection, and this allows you to directly connect one-to-one VPCs together. Now, note in this example that just because A can talk to B and C can talk to B doesn't mean that A and C can talk together. So there's no transitive peering. You can't go through one network to get to another network, right? They don't support that. If you want to have A and C talk to each other, you have to create a connection between them. I also want you to note, look at the IP addresses, 10.1 for VPC A, 10.3 for VPC B, and 10.2 for VPC C. Those IP addresses, right, are remarkably independent and they cannot overlap. So you can't, if VPC A is a 10.2 and VPC was a 10.2, you couldn't connect them together because they won't know how to talk to each other because they actually both think they're the same network. You can connect or VPC peer accounts across accounts. You can also connect with VPCs in other regions. So you can actually connect to Tokyo if you're in Virginia, or if you're in Oregon, you could talk to Sydney. It's like there's no like geographic restrictions for connecting VPC peering together. This, by the way, also works off of routing tables. So if you're in VPC A, which is a 10.2, and you're looking for VPC 1, I want you to note on that left-hand side, which is like right here, that when it goes to look for VPC B, it's actually going to go here, and it's going to route that traffic to VPC B. If I'm over here and I'm looking for the 10.2 network, which by the way is VPC A, I'm actually going to go hit this router, and then it's going to route my traffic up to VPC A. So routing is king here. Routing is what makes all this work. Now here they've got a bunch of VPCs connecting into a central VPC, which in turn is connected to a VPC in another region, and it also has a VPN connection at the bottom down to an on-premise data center. So just know that like you can have a central VPC that accepts all your traffic and just route through that if you want to. This is one way to do it. By the way, this gets really complicated when you have to create all these one-to-one relationships if you're not using a hub and spoke model. But even with a hub and spoke model, it still gets crazy, right? Because VPCs still might have to talk to each other. Now, the answer is, what if I don't want to use that because I've got 1,000 VPCs to like connect to each other, and that is way too much overhead? Well, Amazon has a second option other than VPC peering that is better at scale, and it's called Transit Gateway. VPC connectivity without a transit gateway is going to be everything that you just saw in this crazy picture. If you get 1,000 of these, you've probably got 6,000 connections if you're trying to connect them all to each other, which some people do that. But with a transit gateway, what ends up happening is that instead, at this layer right here, you end up like this layer right here, you end up with a routing layer. So you're no longer having to directly connect all these things to each other. They all talk to the transit gateway. The transit gateway then routes the traffic to the other networks. So this acts as like a true router, but for all of these VPCs and all the subnets in the VPCs. It also acts as a router for all of the VPN connections that you might have, you know, and I can't remember the limit, but it's in the thousands, right, of the number of connections that you can route through a transit gateway. to get to your VPCs, or from the VPCs back to VPN or Direct Connect. So Transit Gateway is considered to be like the thing that we, typically are now using instead of VPC peering. And by the way, all of this stays on Amazon's private global network. It's not exposed to public internet. And you can route to other regions. So you can connect transit gateways together if you want to. Now, Transit Gateway also supports VPN, can route to specific VPCs, can route to other direct connect connections. Those are the physical wires from your data center to Amazon's data center. So it supports a lot. It does operate at layer 3, and so it basically does it based on destination IP addresses and routing tables. That's it. So you have route tables that route all these different connections through the gateway back to all these different connections. Now you have to attach these networks to the transit gateway and then specify how you want them to find each other. And then you can actually propagate routes. So if someone automatically adds a VPC, it automatically gets added to the transit gateway. So if they add like a new network or something, right? So this allows you full connectivity between all of your VPCs, all of your direct connect connections, all of your VPNs, and it all is routable. Everything can talk to each other. You can also isolate it and say, look, right? Maybe all the VPCs can talk to each other, but maybe we want to isolate 2 of them, right? So the traffic can only go one way. Or maybe we want to isolate even further and make it so that none of the VPCs can talk to each other, but the VPN connection can, the VPN connection can access all of them. So you have a lot of control about how traffic is isolated and routed using Transit Gateway. That's your main takeaway. Remember this though, Transit Gateway supports VPC management, VPN management, and direct connect management. So it will actually allow you to manage all of the different major networking components that can be connected to Amazon's networks. Questions of any type about this, the concept of peering VPCs directly together, or VPC endpoints for keeping traffic private? Okay. All right, so then the other question is that let's talk about VPN and Direct Connect, because I don't know that we had a conversation about it, right? So first of all, just know that you can actually connect your router at your house if you want to into AWS, as long as it supports site-to-site VPN, right? If your router supports site-to-site VPN at your home right now, you can connect into AWS privately and encrypt all your traffic going between you and AWS. Now, most enterprise devices will support this out of the box. So it is a managed connection, and basically what happens is that you are connecting your networking device, which is like here, and you're connecting it over the internet to Amazon's virtual networking device over here, and then you get access to this VPC, and then you get access to the AZs that are listed here, right? Note that it's going to maintain 2 connections, right? So there's 2 endpoints inside of that VPN tunnel. Each tunnel, I think, supports, I want to say it's like 20 megabits a second or something like that. I could be wrong about that, so don't quote me on that one. Anyway, each tunnel does support a certain amount of speed. So you can create multiple VPN connections if you want to that virtual gateway device. That virtual private gateway is actually a virtual device, so it's not actually like a single static device. So it automatically has failover included in it. Now, here's some other options where you connect to a virtual private gateway, or you could connect into an EC2 instance. So like if you're running OpenVPN and you want more control over the connection, you could actually connect into a OpenVPN server. Just be very careful with that, because OpenVPN, while secure, that does expose you to attacks where things are going to try and hook into your VPN connection. And then, of course, you can use Transit Gateway, which we literally just talked about. Instead of terminating on a virtual private gateway, you could just hook into Transit Gateway instead. So up to you. Now, this is all running over the internet using encrypted tunnels, using what's called IPsec with IKE version 2, which is like, an encryption algorithm, really. So what's happening here is that you're running all of this over the internet, but it's encrypted. This option, Direct Connect, has you running over your own private wire. It is not encrypted though. So you'd actually have to run VPN inside of this like cable if you also wanted to encrypt it, or you'd have to enable encryption end to end, which I think you have to use VPN for. I don't think they support that natively, right? Actually, that's not true. You can't actually use something called MAC-SE, MACsec security. You can use something called MACsec security on here. You don't have to actually use VPN, but only if your device supports MACsec security. That's like one of those weird 802.1.ae, parameters inside of networking. So your device has to support that MACsec security though. Now, oddly enough, you're actually connecting to one of Amazon's partners, and Amazon's partner has a connection out to AWS. So you actually never, you can't trace your cable because you're actually terminating at a partner, and that partner is allowing you to run over. It does require you, by the way, to have a device inside the partner's network, and they usually will allow you to either rent or buy one if you want to, right? And so you're actually connecting to a direct connect location, which is then connecting over to the partner. That way you can't actually ever find out where Amazon's data center is. You're actually connecting to an external networking substation, because you could find that wire if you're connected to it, but then they terminate it there, and then they're connected to Amazon, but they're not telling you where that wire goes. I mean, let's be clear. You could Google Amazon's data centers and probably find at least one of them. These direct connect connections, by the way, are available in sub 1 gigabit, 1 gigabit, 10 gigabit, and 100 gigabit connectivity options. So that's 100 gigabits a second. Sorry, that's 100 gigabits. That's 100 gigs per second, gigabits per second. So this is predictable networking performance. If you are ever asked a question on the exam where they're like, we need predictable, steady network performance and throughput, the answer is always going to be direct connect. VPN runs over the internet, so it's not going to be steady, because if all of a sudden people start watching Netflix at 10 p.m., your internet connection is going to slow down, right? It's not about cable, by the way. I'm talking about the tier 1 backbone is going to slow down. So just know that if the question asks you for steady bandwidth, you're going to use direct connect. If it says encrypted traffic, by the way, they're going to assume that you're going to run a VPN, because that's encrypted by default. Direct connect is not encrypted by default. Okay. Here are some direct connect options. So for example, just to highlight these because they didn't do the same thing they did last time, you can actually connect to a virtual private gateway, which is exactly what you can do with VPN. You can actually connect to what's called a special direct connect gateway, which is actually something just special just for direct connect. Or you can use transit gateway, which is something we stated before. In general, most people are going to use these two: virtual private gateway or transit gateways. Now, this whole private VIF versus public VIF versus transit VIFs, I'm not going to explain that because that's a professional level deal. They're not going to ask you any questions about VIFs, right? So those are virtual interfaces. Just know that you got 3 options. You can use the direct connect gateway, you can use the virtual private gateway, or you can use the transit gateway to connect direct connect into your systems. Okay. Questions of any type about either direct connect or VPN? All right, let's talk about DNS. DNS, what does it do? We all know because we use it every time. We type it in our browser, www.amazon.com. That resolves the name, amazon.com, to an IP address. Is it IPv4, IPv6? Could be both. Now, what's going to happen is that you can use Amazon as a full registrar if you want to. So you can actually register or transfer a domain name. Requests can be based on latency. This is DNS a little bit like kind of pumped up, right? So Amazon has a bunch of options for DNS that are over and above what you would expect for standard DNS. Although I think it's become standard because Amazon did their thing here, right? So note that when you host your DNS records, you're either going to allow public internet-facing resources to be exposed, or you're going to have private, like VPC-only resources to be exposed. Those are called public and private hosted zones. So public hosted zones are for the internet. Private hosted zones are just for you and your VPCs, right? So you can create these zones where you actually have like records saying, www.amazon.com. If you're inside Amazon, it might resolve differently than if you're outside Amazon. So something to know. Now, in addition to doing public internet-facing resolution and private resolution, you can also set up these really cool routing policies. These are not load balancing policies. Just to be clear about this, this is DNS routing. And the reason I mention this is that customers will cache what DNS gives them as a name. So sometimes this doesn't work as well as you want it to because people don't honor your DNS settings. They just do whatever they want with the DNS resolution. So most of the time this works exceptionally well, but every once in a while you'll run into customers who will not follow the routing policies that you're publishing. So just something to be mindful of. Notice there is a ridiculous number of policy options here where you can actually fail over between two data centers. So this is failover routing. So if one goes down, it routes all the traffic to the other one. You can weight that, by the way, and say, look, I want to put 20% of my traffic here and 80% of my traffic here, right? But here, obviously, 100% of the traffic is now going to that US East data center. You can route based on someone's location. So for example, if someone is in like France, send them to Frankfurt. Or you could force them, hey, if you're in France, go to Spain. So this is based on like where the user is coming from. You can also do geo proximity, which is different than location. Because someone could be in France and they could be in the northern part and closer to Germany, and they can be in the southwestern part and closer to Spain. So geo proximity says which of my data centers is closer, right? Now you can also increase the bias or the range of a data center and say, look, if someone's within 1,000 kilometers of Spain, I want them to go to Spain. That's called bias, and you can increase the bias of a data center if you're like, hey, this is my biggest data center. I want you to go here instead. Then we've got latency-based routing. It says who's faster. So this says who's closer, which is not always faster, by the way. Latency-based routing says, hey, who's faster? Is Spain way faster than Germany, even though I'm closer to Germany? Well, I'm going to Spain, right? Notice that the lower latency here is 76 milliseconds of latency. That's where the traffic's going to go. So then we've got multi-value answers, which is where we're doing round robin on a bunch of servers. Don't do this. Please do not do this. This is fraught with peril, and people are going to save those IP addresses. In general, multi-value is really frowned upon unless you just have no other option, right? It is not a substitute for a load balancer. The documentation will tell you that, right? So, try not to use this. Use a load balancer instead, right? Or use failover routing. If one of your ELBs goes down, then, go over to the other ELB. And then weighted routing was the thing I was talking about before, where if you have a bigger data center than a newer data center, or you just want to do a blue-green deployment, like a canary deployment, where you put a little bit of traffic over here and a lot of traffic on the existing system, and then slowly turn the dial so that more traffic goes into the new system, you can do that with DNS, right? So that's all Route 53's kind of like server-side options. Now, unbeknownst to most of us, when we launch a VPC, we're actually using DNS inside of AWS. We're using Route 53 internally, and that just comes to you for free. That's just how Amazon does it, right? Just note, though, that you can create these resolution endpoints both for inbound resolution and for outbound resolution, if you need to, so that if someone is looking for a resource on your on-premise data center, you can have Amazon resolve that for you so your EC2 instances can get to your on-premise servers. You can also make it so that if a resolution comes in from your on-premise network across Direct Connect, they can redirect you to an AWS service. So just the point to all of this is that you can control DNS across your entire AWS account and how it points to your on-premise resources and how your on-premise resources point to AWS. So you can get complete control over domain name resolution inside of your AWS account. That's the main thing you need to know about this Route 53 resolver. Okay. Questions about DNS resolution of any type? Is Route 53 the only way to load balancer between load balancers, especially in the situation where one region goes offline? No, actually. So Kyle, there's a relatively new service, and I say that I think it's been around for like 2 years now, called Global Accelerator. They don't really talk about it in this class. They talk about it at the pro level. Global Accelerator is a global load balancer. So it's not a regional load balancer like the ELBs are. It's a global load balancer. It gives you a single IP address, and you can attach multiple regions to that IP address, and that IP address works all over the world. So, and that IP address will direct you to the closest region that you have, and that is actually true load balancing. Like it's a true load balancing redirection. So, and you can weight it. So like you could say, I want to load balance between two regions. That's the global accelerator. So unlike DNS, which is just a routing option, the global accelerator is really kind of a true load balancing option. It's a global load balancer. So I would use that if you're trying to do failover. I actually wouldn't use DNS. Oh yeah, that's more for just decreasing latency. It'll do failover as well. I know the name kind of sucks. I was like, why don't you just call it global load balancer? Global accelerator makes it like you said, this makes it sound like it's just gonna like be like CloudFront. It's just gonna accelerate latency. It doesn't. It actually load balances. So like load balances between regions. So to be clear, right? It still lets the ELBs do the actual load balancing between the systems, but if you need to redirect traffic to different regions, that's the best way. So. All right. So Jorge, you're asking me, is AWS down? What's the problem you're having? Just out of curiosity.
I'm dark and it's too much to type. I just basically, the company, two different sources, is not able to access their resources. And I attempted to connect to the console just as myself, and the site cannot be reached. So I was just asking just to double check from the expert.
Oh, let's go check this. Let's go check the service health dashboard.
Mm-hmm.
According to them, it depends. It doesn't say that they're down. Now, Amazon.com. Yeah, as far as the console goes, let's see. Actually, it's probably going to log me out because I haven't been logged in for a second. Let's go figure it out. MFA for the win. Okay, there we go. Huh. No, everything looks good on my end, but that's not necessarily an indicator. And status shows that everything's cool. So I'm hoping they're not down again. That would really suck. They haven't had a global outage in a long time. To have another one so soon, oof, that would hurt. So, okay. That's a good point, actually. Sometimes they don't know, right? Although I will tell you that often they'll put like there's some kind of degradation going on, so they might be having another problem. Yeah, just because we looked at it doesn't mean there isn't an issue. I didn't actually try and start anything. I just logged into the web product, right? Hopefully though, it won't affect us, but we'll see. So what's the network connection to a transit gateway called? So what do you call when you actually like hook or connect a VPC or a VPN or a direct connect? What do you call it up to a transit gateway? Good. Yeah, B is definitely it. It's an attachment, right? So you attach it and then you can manage the network connectivity between it at that point. All right, so what are the two components of a site-to-site VPN connection? What do you need on both ends in order for a site-to-site connection to work for a VPN connection? Good, yeah, customer gateway device and a virtual private gateway. The virtual private gateway is on AWS's end. The customer gateway device is on the customer end. Okay, what is true of VPC peering connections? Are they one-to-many? Are they one-to-one? Do they require a transit gateway? Can they span accounts? Are they transitive? Hopefully we answered these really clearly. So they are one-to-one, definitely. And they can span accounts because you can actually VPC with VPCs in other accounts, right? That's another way, by the way, for you to get access to services in like a vendor's account is they'll initiate a peering connection with you. So they're definitely not transitive. Amazon still doesn't support transitive connections despite many conversations around that. How can an application running in a VPC access S3 without internet access? What are the two possibilities of routing traffic privately if you're on a VPC and you want to get to S3? Good, C and D. Perfect. All right, that's the end of module 10. Here's my recommendation is that just because, things are going to be interesting today, let's actually just take a short break. So let's take a 10-minute break. I know we're only like an hour and 20 minutes away from lunch, an hour and 30 minutes or so. But let's take a 10-minute break. So it's 10:30 now. Come back at 10:40, okay? And then we'll finish out and we'll set you up for a lab and all this other stuff in our next section, okay? All right, we'll see you in a bit. All right, welcome back. Jorge, I saw your thing about US West not being online. That cracks me up. Most people avoid US West 1 like the plague.
Well, I was a beginner. Just got the closest one to me.
Oh, this is for your own use.
Yes.
It's funny though. Kyle called it. Still nothing showing up in the status page. Huh. All right, we're going to talk about. Oh, hold on. Huh. You know what, Kyle? I can ask them directly if that's true, actually. All right. I think we're going to talk about serverless next. A little interested about the structure of this. It looks like they switched it around. All right, we're actually going to talk about serverless next. Okay. Sorry, just a weird logistics on my end. Just trying to figure that out. All right. Here's what we're going to do. We're going to talk about serverless for about maybe 30 or 40 minutes. And then actually, oddly enough, we're going to do a lab, and that'll be actually pretty good. Yeah, I will actually email my friend Bobby over at Amazon and ask him, because he actually is responsible for some of the support stuff. Let me pre-warm this lab, share my screen. We're going to be good to go. All right, so that should be all warmed up. No, I did not want PowerShell, but thank you for that. Okay. So let's talk about serverless for a second. Now, let me ask you this simple question. What are you responsible for if you decide to use Lambda to host your application code? That's actually pretty straightforward. You're not responsible for anything other than just writing the code and uploading that code up to AWS and answering a few questions. No OS patching, no managing the servers, none of that scaling stuff. None of that's your responsibility when you're using Lambda. So that's it, writing the code. Now, serverless is a very simple topic to skim, but a very can go deep, right? Like this is an easy service to use, but it has a lot of features to it. A lot of people are looking at serverless now because honestly, there's just so many great use cases for it. And when you don't have to manage servers and you're okay using AWS, it's a lot more efficient. There's no more like ROI. You're actually paying for what you use and you're not paying for capacity, right? That's a big difference. There are also other things that kind of go around Lambda, such as like processing data in real time. How do you do multi-step Lambdas? Like if you want to do a workflow, how do you send notifications? How do you do event-driven asynchronous architecture? Like how does all that function? This is all part of event-driven architecture, but it's all basically about how you use functions as a service, which is Lambda is in that industry class of, since it's serverless, it's like functions as a service. How do we make functions work as a product? Oh, wow. I forgot this was here. Man, this huge eye chart. Holy cow. Anyway, this basically, if you look at where it says the Lambda, the thing that looks like a funky little A, if you look at where the A's are, this is where Lambda can actually like be orchestrated as a product. That's basically what this is showing you. Now, the cost of this is probably a little bit more complexity, But things like step functions, AWS step functions, and AWS Event Bridge, and I do that on purpose so you know I'm talking about services and not just making up stuff. These things can coordinate the use of Lambda into this multifunction product. I don't need you to even remotely memorize this. I just want you to know that Lambda can actually fulfill all of the different functions of an application, right? Now, then that begs the question, what is serverless? By my previous definition, I define serverless as hidden servers. Meaning you just tell Amazon what you need, you pay for as long as it runs, you do not pay for the servers anymore. I like serverless because you don't pay for the servers. When Amazon manages the servers, you typically don't pay for them. The only exception is like RDS. You still have to pay for the servers because that's the only unit of capacity. But if you're using serverless Aurora RDS, guess what? You don't pay for the servers. This scales automatically. So if you want to invoke them this 1,000 times a second, you can. You don't have to change anything. You want to invoke it 10,000 times a second? Well, you're going to have to raise your account limit, but that's possible. So if you want to run 100 instances of one type of Lambda function and 200 instances per second of another type of Lambda function, you don't have to configure anything other than the Lambda itself. Now, like I said, it has a bunch of other things that are typically associated with it, like external databases, GraphQL, which is what AppSync, is, S3, Kinesis for real-time streaming, Managed Kafka for real-time streaming, step functions, which is an orchestrator. There's all this other stuff that you could use with Lambda if you really wanted to. You don't have to, if you want to. So, by the way, we are going to talk a little bit about API Gateway, SQS, SNS, and Kinesis, which are adjuncts to any application, not just Lambda. So you don't just have to use Lambda for for these services, but we are going to talk about a few of these. Now, in a serverless architecture, for example, someone here uploads an inventory file to an S3 bucket. It gets processed by Lambda, dumped into a DynamoDB table. Lambda receives the updates from the table, so that triggers another Lambda, which sends a notification to the user that their file was processed at the beginning. This is the kind of thing you can do with Lambda, is that you break your application into these discrete functions that get triggered based on events. User clicks here, user uploads a file, user visits a website, user does this with their mouse. You get the idea. So let's talk about these different pieces. First is that if you need a proxy, you need a system for managing your API presentation to the world, the API gateway, right, we're used to connecting to APIs because we already do this with all the tools with Amazon. The API gateway is a service that allows you to version, meter, chargeback, and control APIs that you publish behind the API gateway. Think of the API gateway as, in a sense, almost like a really simple but advanced load balancer for publishing your APIs for consumption. Now, behind the API gateway, you could have Lambda functions, you could have EC2 systems that are publishing APIs, you could have DynamoDB, you could have S3 endpoints. Anything that is actually publishing an API, including AWS services, can be behind an API gateway. It'll handle, by the way, hundreds of thousands of concurrent API calls, and it will scale up. This includes traffic management and shaping, authorization, access control, versioning, caching. It is a very complex system that can do a bunch of stuff. Unified front end for APIs. It will actually provide distributed denial of service protection. It'll authenticate and authorize, throttle, meter, monetize. It's a really cool tool. It's super complicated. I'm just kidding. It's not super complicated. It's slightly complicated. Like anything we're not familiar with, it can be complicated. This, by the way, will support RESTful and WebSocket APIs. And it will support all kinds of endpoints as well. Here's a sample architecture, by the way. Internet hits CloudFront. CloudFront is fronting the API gateway. So most people don't know this, but CloudFront can front dynamic content. Most people think it can only do static, but putting CloudFront in front of dynamic content will actually help the latency for the end user. So don't feel like that's the only thing it can do. Here, the gateway is being monitored by CloudWatch, which is the default for any AWS service. And then it's actually fronting a Lambda function, which in turn is talking to DynamoDB. And you can activate stages. You can have production versions, dev versions, whatever of your API. You can get metrics on latency. How long does it take to talk to the back end? How long does it take to return to the front end? API Gateway is really awesome. So again, think of API Gateway as a API proxy, like a load balancer for your APIs. Okay, that's the only thing you really need to remember about API Gateway, is that it is an API load balancer or proxy, and it integrates in with all of the AWS services, the standard services. Remember though, on the back of the API Gateway, targets can be Lambda. It could be an ECS container. It could be EC2. It could be anything that's publishing an API. So just remember that. All right, now we're going to talk about SQS and SNS, which are like two sides of the same coin. Okay, so SQS was actually the first service published by AWS. And this cool little service is a fully managed queue service, but it is not industry standard. They do have a managed MQ service. So if you want to run ActiveMQ, which isn't as highly available, but it's still good nonetheless, because you want something industry standard, they do have an MQ service that you can use. But SQS is a fully managed system. And what it does is it allows you to dump messages into it. And they're only 256 kilobytes in size, but you could dump 100,000 messages into this thing within a few seconds. And it allows then the application servers to come and just process the messages without you just overwhelming the application servers by dumping a bunch of messages on them. So this acts as a buffer between the front end and the back end. So it's like a trough, it just dumps a bunch of tickets in there, and then you can process the tickets. And it does actually guarantee, even the standard queue does actually guarantee at least once, it'll be processed at least once. The FIFO queue, first in, first out, actually guarantees they'll be processed in order of when they were put on there, which is kind of nice. FIFO only came out within the last couple of years. Before that, we all had to deal with, well, we're not sure if ticket number 1 is going to be first or not. It could be number 3, right? So without SQS, you can easily overload your connection between your front-end web servers and your application servers that are processing your tickets. That would be the consumer tier. If you throw SQS in there, what will happen is you can dump your messages into this queue and then just have them processed as the backend can actually do it. Now, SQS is pretty cool because SQS can actually trigger auto-scaling, so you can actually grow your backend queue if you want to increase the speed of order processing. And if for some reason a message is not processable, did I just make that word up? Can't be processed, you can actually stick it into a dead letter queue and have a system just check that dead letter queue on occasion and troubleshoot why something on order couldn't be processed. These queues, by the way, are highly redundant, so you're not going to lose any messages if you use them, right? And you can retry order messaging. It has visibility timeouts and all this cool stuff on it. So SQS is where you go and you pull the messages off for consumption. So it's a pull or pull model is what they call it. So, this is a great use for asynchronous processing where you might have a surge or scale and you need to create a buffer between your front end and your back end, right? Great for work queues, great for auto scaling, great for just offloading asynchronous requests. What if somebody comes to you and says, I want to report for the entire year? And you're like, that's going to take 5 hours. So you dump that off to a separate queue, and then maybe it shoves the job off to Redshift. And then once Redshift finishes the job, SNS could trigger a notification that says, hey, by the way, your 5-hour report is ready to go, right? But then that way, Redshift could just continually process what's in a queue instead of having to directly receive the request, and yet it's already got one in flight, and it's going to take 5 hours, and someone just asked for another 8-hour job. SQS just allows that to all flow asynchronously. Now, I did mention that there are standard and first in, first out queues. The standard queue is almost unlimited in the number of transactions per second it can handle, like the number of messages you can put on it. A FIFO queue actually has a limited number of calls, right? The main reason for that is that FIFO is trying to control the order of execution. It doesn't mean you can't dump a million messages on there. It just means it might take a minute for you to get all those messages there, right? So just know. So standard could be out of order, but will guarantee processing. FIFO is going to be in order, and it also guarantees at once processing. Now, SQS as a queuing service has, all these features to it, including reprocessing, short and long polling, how to control visibility timeout. One thing to note is that when you produce a message, it actually gets dumped invisibly to you on a number of backend servers that AWS has representing your queue. And then what happens is that the consumer will come and grab the message, and what will happen is that message will go invisible. It's called a visibility timeout. And the message will be invisible so no one can see it. That consumer has until that visibility timeout expires to process and then delete that message. If the consumer fails or doesn't come back within the time period, then what will happen is that message will become visible again. Another consumer can pick it up, and then they have to come back and delete it within the time period. If they don't, then it'll become visible again. And so this guarantees that it's processed at least once. Now, can you get this wrong and set the timer too short? Of course you can. Can you set it too long? That's arguable. If your job isn't going to get processed within a certain time, that's too long, right? Now, these SQS servers, the queue itself, will hold on to this message for a maximum of 12 hours. The default is 30 seconds. So just know that you can control how long it's invisible for if you want to. The default is 30 seconds. Now, the consumer can only delete the message if they've read the message. So some other consumer can't come in and just delete messages. The only way for you to delete a message off of the queue is if you've read it and processed it first. So that guarantees that everything's processed at least once. Now, you can also do what's called long polling versus short polling, which means when you come to the queue and say, hey, do you have a message for me? You might get a wise guy server, that's what I jokingly refer to it as, where there's a wise guy server who doesn't talk to the other servers and just says, hey, man, I don't have any messages for you. That's short polling, right? That's where you get the wise guy server who's like, I just talked to 3 of my buddies. I didn't talk to the entire team. We don't have any messages for you, right? That's short polling, which means it doesn't actually check all the servers. It just checks 2 or 3 of the servers. But it gives you a really quick answer, right? Now, long polling is where you don't have a wise guy that you've talked to, a wise guy server. You actually go in and you say, hey, do you have a message for me? And the servers that you're talking to says, wait. And it talks to every server that makes up your queue, says, hey, do we have any messages for this person? No? Because meanwhile, by the way, it's telling you, wait, let me check. Wait, let me check. Wait, let me check. You know what? I talked to everybody. I got nothing for you, right? So long polling takes longer, but it's more efficient because it actually talks to all the servers that make up your SQS queue. Short polling is like that wise guy thing I was talking about, where it's like, well, I talked to one server. I talked to 3 of my buddies. The entire team doesn't have any messages for you, right? Which is a little weird. But this one is shorter and quicker and won't hold connections open. I got to tell you, though, most people prefer long polling, and that's what they tend to use. They don't use short polling, but short polling is the default. So, just to say this, if you have one thread on the consumer side to talk to SQS queues, this can tie up your application. So make sure you're using the software development kit to get around that. And then the dead letter queue is just used for when something, for whatever reason, just can't be processed. That way it's never lost, right? It just gets dumped into this queue. You go check it once every hour or once every 5 minutes, whatever your SLA is. And then basically it guarantees that messages are going to get processed. Now here's some messaging use cases, right? So this is great for asynchronous processing, for any kind of buffer that you want to put between a front end and a back end. These are messages, so they're not going to go above 256 bytes in size. So you're not going to throw objects on here, you're throwing messages on here. Okay. Now that's all SQS. That's the simple queuing service. It has a sister service called SNS, which it doesn't allow you to come and pull off of it. It pushes messages to you. So you can send alarms and notifications, but you can also send texts, web posts like HTTP posts. You can send a trigger to Lambda. You can trigger all kinds of things with SNS. So in this particular case, you're going to have a publisher and you're going to have a subscriber. And what happens is that we know how this model works. This is called pub sub because we do this with our email all the time. We subscribe to something and we consent to receive messages from that publisher. This is this simple notification service. So messages are published to a topic. We receive those messages about that topic, right? And this is what we use for like mobile push notifications, email notifications, system alerts. But again, this could be a Lambda trigger or a web post. So you can get a single published message. There are no recall options. It guarantees delivery to the end system. Doesn't necessarily mean it guarantees that the reader is going to read that, right? And it will have standard or FIFO queues, and you can also filter messages. So SNS, by the way, will attempt to deliver in the order that was presented to you. So here, a publisher setting a topic that actually hits multiple SQS queues, and that sends a message to a subscriber. So SNS, by the way, does not maintain message persistence. It does not hold on to the messages. Once you send it through SNS and SNS delivers it, the message is deleted. SQS, the previous service, is going to maintain persistence on the message. It's not going to let that message go until you go and delete the message, or 12 hours. Wait, is that right? 12 hours? Actually, I think you can set it up to a week for the retention period for the message. SNS is designed to take one message and publish it out to many subscribers. SQS is meant for one person to receive the message and process that message. So one's a queue, one's a notification service. Questions about SNS or SQS? By the way, has anyone ever used either of these services inside your either application or even just configured it from an infrastructure perspective? I have to say, in most enterprises who are using AWS for any number of years, usually find people using both for something. So good. Okay, we got two kind of relatively short ones just because we can't get deep into these two topics, kinesis and step functions, because they're rabbit holes in and of themselves, and they are really deep inside both the developer track and in the SA Pro track. Here's what you need to know about kinesis. It is a streaming service. Its job is to receive either data streams, video streams, any kind of data stream really, and it could be website clicks. It could be IoT telemetry data. Its job is to ingest this data in an ordered fashion, and then allow people to consume it like it's a river of data, so people can just take the data they need. So you don't have to wait till the data is processed, right? You're collecting the data. This is what this is it's data collection, and you can even actually do some analysis on it before you ship it off to the final place where it's going to live, right? So this is going to allow you to collect, process, and analyze data in real time. This is built for real-time processing. So if the question on the exam says something about real time, they're either talking about Kinesis or they're talking about managed Kafka. Most of the time they're talking about Kinesis because Amazon loves their own services, right? Not that Kafka isn't a service of theirs, but you get the idea. There's 4 different flavors. If you're going to dump your data into a data store, you're going to use Data Firehose. right? If you're going to do analytics on this data, you're not going to dump it into a data store. You're going to use any of the others, either data streams, data analytics, or video streams. Now, here's data streams. So Kinesis uses this concept of shards. I wish they had just called them servers, because quite frankly, that's what they are. They're tiny little servers that have bandwidth attached to them, and they can ingest data, and they can express data, right? So they can take data in and they can offer data out. Notice that they can ingest at 1 megabyte per second, and they can, share that data out on the back end at 2 megabytes per second. So if you need 100 megabytes of outbound data transfer, you're going to need to create 50 of these shards within that Kinesis stream. They're just tiny little servers that have bandwidth associated with them, right? So each of these little shards are part of a stream. So if you need more bandwidth, you got to add more shards. You got to like, I know it's going to sound weird. You got to shard the shards. You got to split the shards, right? If you need to ingest more data on the front end, well, you got to create more shards. By the way, the data, when it hits this stream, is partitioned with some hash value across all of the shards. So there's this like kind of load balancing thing that happens where all of your data is split across all the shards that you have inside of a stream. Kinesis is old, by the way. Old, oh my God, it would kill me. It's still being iterated upon. It's not an abandoned service. Amazon doesn't abandon any of their services. But it's been around since like 2013, 2014. So this service has been around for a while, well before Kafka rose in popularity, right? So this allows you, again, to collect, analyze data in real time. And the consumers on the back end who are sipping up and digesting all this data, it could be anything. Anything that can actually talk to the API can be sipping this data off of the Kinesis stream. So you got producers who are dumping data into the Kinesis stream. You got shards that make up the stream. And then they're dumping data into what's called consumers. Consumer could be a lot of things. Now with Firehose, unlike with data streams, which we were just looking at, with Firehose, it's dumping right into a database. And that could be, by the way, a third-party provider. It could be HTTP Post. It could be Elasticsearch. It could be S3. It could be Redshift. It could be RDS. It could be a lot of things. So notice that we didn't talk about video streams or the data analytics pieces. Those are really advanced topics. Just note that we didn't actually do the last two, data analytics and video streams. They're not going to ask any questions about those. But data streams and data Firehose, the main difference you need to know between data streams and data Firehose for your exam is that Firehose is for dumping data into data stores. Streams is for real-time analytics. Okay. All right, last but not least, let's talk about step functions. So you know how we talked about containers yesterday? We said, hey, we've got containers, but then we need something to orchestrate the distribution of all these containers. Guess what? Lambda is a simple piece of software, but if you've got 100,000 of them, or 1,000 even, how do you orchestrate how all these Lambda functions are going to run? How do you orchestrate a workflow for a product? Well, this is where step functions comes in. Step functions allows you to create microservices with Lambda functions by creating a user's journey through your product, and you attach Lambda functions to each part of this journey. Now, step functions, just to be clear, doesn't just have to manage Lambda functions. It can actually talk to like DynamoDB, containers. It can talk to SNS and SQS. So you can actually orchestrate an entire workflow system just using step functions. It has its own proprietary domain-specific language that, it's in the AWS documentation, and you can do things like, well, a user comes and clicks on this, and that triggers an order. Then we find out what state is the user in. Oh, they're in Arkansas? Well, we have to do this. Every other state do this. And then you can have conditionals, workflows. You can have things done in parallel. It's basically a state machine that tracks tasks, choices, and error handling. That's what it is. So you can use this to actually orchestrate applications for your usage, again, using Lambda as the primary vehicle. Here's the language, by the way. In this case, there's a start state kind of like stage, and then there's the final stage, because it goes through different states, right, from start to finish. And you can do all kinds of things. There can be workflows, like you can have conditionals, you could like check for an address, wait for a review, get human approval, right? You can have fail and succeed states. You can wait 2 days and then, check. So it's pretty cool service. Here's a pretty complicated workflow where someone's posting data against an API gateway on the over left. And that triggers this whole thing of we're going to look up the customer number, we're going to generate a reference number, we're going to record the transaction in DynamoDB. Was that successful? Awesome. Was it not successful? Send a notification to an admin and say, man, we got a problem. So this workflow service called AWS Step Functions can orchestrate whatever workflow you want. If it seems complicated, it's actually no different than what we do when we design an application and write it monolithically. The difference is that you're now not going to write it monolithically. You're going to write a bunch of Lambda functions and orchestrate that workflow inside of Step Functions. Okay? So think of Step Functions as an orchestrator for Lambda. That's what it's mainly used for. Okay? Questions of any type about Step Functions? Okay. Let's do a quick knowledge check then. Which type of Amazon SQS queue provides at least once delivery? Well, a better question. What's the queue, the lowest queue that provides at least once delivery? Good. Yeah, the standard queue provides at least once directory delivery. The FIFO queue provides ordered delivery, so it's more than just at least once. Okay. All right. Ignoring my whole wise guy thing, although that maybe helps you remember it, right? What's the advantage of long polling compared to short polling, right? What's the problem with talking with a wise guy? You may not always get the truth, right? That's why they call them wise guys, because it's a sarcasm. So which of these would then make sense, right? Yeah, I pointed out that single threads with long polling would not be stable, actually, because that would choke you out, right? Well, remember, long polling is going to check with the entire team. Does that take longer or shorter than short polling, right? Yeah. So it's going to be C, right? Because remember, long polling is where instead of just like talking to a small subset of servers and then having to check back again really quickly, when you do long polling, you're going to check all the servers. This is going to reduce the number of empty responses that you were getting because it's going to say, hold on, let me check with everybody before I give you an answer. It's going to give you a more accurate answer if you use long polling. Now, if you're single threading, that's going to be a problem, but you shouldn't be single threading anyway. It's 2021. Talk to me. Talk to me if you need free consulting on that, right? So long polling is going to reduce the number of empty responses and false empty responses that you get. And then what's a feature of SNS? What's the simple notification service used for, right? What's a characteristic of it? Good. Yeah, so it's designed for that fan out model where you can publish a single message to multiple subscribers. That's what it's built for. No different than our email subscriptions, right? You think you're the only one getting spammed? I'm getting the same messages, right? So just keep that in mind. Good. All right, that's the end of module 11. Okay. That was a little bit of a run around just like Lambda and then API Gateway and SQS and SNS, because we talked a little bit about Lambda in one of the previous modules, but this is all about the extra stuff, right? About all the stuff around Lambda. All right, so let's talk about this lab that we're about to do. So this is lab 5, build a serverless architecture. This should already be pre-warmed. So if we open up the lab, what we're going to see here is that you're going to create an SNS topic, which is good because we did talk about it. You're going to create 3 SQS queues. Now, I cannot emphasize this enough. Please make sure that you are in US East 1 up in the regions. Amazon fixed it because I raised a lot of noise about it about 2 months ago. Every once in a while, though, people's regions will change to a different region. If you put these resources in different regions, they're not going to be able to talk to each other. So just make sure, on the minute you switch to a new service, just make sure it says US East 1 up there. So 3 SQS queues. Then you're going to create an S3 event notification to SNS, which is going to be fun. You're going to create 3 Lambda functions. And make sure you get this execution role attached to it, otherwise it won't have permissions. You're going to add a trigger. You're going to download this zip file to your computer and then upload it up to the system. And it's going to basically use Python to basically do some things, right? And then you're going to upload an object. You're going to take basically a file, 3 JPEGs, Mona Lisa, Happy Face, and AWS. You're going to upload those to your S3 bucket. That's going to trigger some processing, and then you're going to validate the process file. Now, oddly enough, this is typically considered somewhere between a 30, 45-minute lab. So let's go ahead and get cracking on it. So just go ahead and hit Start Lab in the upper left-hand side. That's what we're going to be doing. Now, at about 11:55, I'm going to switch gears over to do my webinar. But officially, when you're done with this lab, we're taking lunch, and we're actually not going to come back until 1:05, because sometimes my webinar runs just a little over. We're going to come back at 1:05. We're going to talk about some exam prep stuff, and then we're good to go. So meanwhile, you work on lab 5, and I'll let you know when I have to leave to go teach my webinar. And at that point in time, you're at lunch, okay? So that'll be in about 40 minutes. Sorry, I lost connection there for a second. If anybody talked in the last few minutes. Let's see, Kyle, what topic is the webinar on? It's on learning certifications in AWS. So it's about how to study for the certifications. I have a recording for it. Actually, I'd be glad to share with everybody into your playlist. So you don't have to attend the webinar if you want to. But if everyone's interested, I can actually share a recording with you. Yeah, no problem. I will just put it in your playlist once this last video uploads so you all can have access to it. It's not specific to any company, by the way. Just general steps on how to study. Yeah, it's got like a 7-step process. It actually takes the documents that you all are using and kind of shows you how to use them. So, you know what? I don't even know why we didn't do that to begin with. I apologize. We should just have that done as a matter of course. I didn't know why I didn't think of that, actually. So I'll make sure that's stuck in your playlist. So thanks for asking, Kyle. It's been a crazy year. I don't necessarily feel like I'm necessarily right on top of everything. So I really appreciate you asking questions that prompt these responses. So. Kyle, there is a mention at the very end about the Tech Excellence Program, about its existence and where to get more information in that webinar. So in the video I share with you, I believe it's listed at the very end as well. It's on like in Indeed, or you can ask on Yammer. They'll have information about that. It's like a 14-week program that covers, basically everything related to CI/CD and cloud, and a little bit of like a couple of weeks on Docker and Kubernetes. So it basically covers like more kind of cutting edge technologies and how to use cloud and how to incorporate DevOps kind of principles into that whole process of delivering applications.
Okay.
Yeah.
How in depth would you say it goes into all of these? Because I know this class is just scratching the surface, but if you would like put it in perspective to this class compared to how much that covers.
So that class covers the official system operations on AWS content. So it actually covers Cloud Practitioner and the actual System Operations Associates. So it's a slightly different focus because this one's actually focused on more on architectural pieces. That one focuses like, for example, systems manager is covered over there, but it's a deep dive, right? A deeper dive. Sorry, not a deep dive. It's a deeper dive. So it's like a different set of services and a deeper dive on the ones related for any kind of DevOps, SRE, sysadmin role. I would say though, from my perspective, it's hard to qualify. I think it's like kind of a beginner's skim. In other words, it teaches you about APIs and you write an API. It teaches you about CI/CD and you create a loose pipeline. So it does do those things. So I think it's beginner to intermediate, but it's not like master level. It's not going to deep dive into Jenkins. That would be a whole week course in and of itself, but it does touch on Jenkins as an example. It's not going to deep dive into like all of the different facets of Systems Manager, but it's going to tell you what the 11 subservice, well, I guess 17 subservices are for Systems Manager, and you'll get to touch 4 of them, right? So it's slightly deeper with a slightly different focus. So, but I wouldn't call it like an advanced class, because if you're looking for advanced, then that needs to be specialized. So like we teach the fundamentals of Docker and Kubernetes, but if you were looking to get really deep on Kubernetes, then you'd probably want to take one of the administrator classes and not the fundamentals class, which is what the Cloud Excellence is included with.
Okay, good to know, because, for example, I've been doing Kubernetes I've been drowning in Kubernetes administration for the last year.
That's how I know you've been doing Kubernetes, if you say you've been drowning in Kubernetes, because that's definitely the way it feels, especially for the first year or two. So, yeah. So if you've been doing that, by the way, you'll be bored in the class. And don't get me wrong, it'll teach you architecture and fundamentals and stuff, but as far as like administration goes, you're going to be like, well, that's it, right? So, yeah, it won't be as fun.
Good to know.
AWS does have a deep dive into EKS, by the way. It focuses into the Elastic Kubernetes service. It's called like deploying microservices on EKS or managing containers on EKS. But if you want a deep class, then you're probably going to need to. We have a CKAD class. That one is a really deep hands-on dive. But I don't really know if like anyone like. I've seen Kubernetes master classes out there, and I go and take them, and they're like intermediate. They're not like deep level. But then I go to Red Hat, and they're like, "Hey, we're going to write an operator for Kubernetes," and I'm like, "Holy cow, really? That's crazy," And then so it's like I can't find that sweet spot between I'd like an advanced class, but I don't want to, I don't want to get pummeled by having to write Go to extend Kubernetes' API. You know what I mean? So
that's fair.
Yeah. By the way, if you haven't seen, if you're doing Kubernetes, if you haven't seen killer.sh, have you seen killer.sh? Go take a look at that website. You can get test scenarios for Kubernetes there. Ooh, they're awesome.
Ooh.
Yeah.
Going to favorites bar.
Yeah.
Helpful.
Yeah. So if you ever need to take the exam and you need to practice, I think for like a small fee, you can get access to the environments. Ooh, man, those things are intense and they're fun. Calvin, to answer your question, I'm actually in Atlanta. So I used to fly to Northern Virginia all the time back before COVID, but all that stopped. So. All right, so I'm just giving you a 5-minute warning that I'm going to be stepping out here in 5 minutes. We are going to reconvene at 1:05. We will continue with edge networking and an edge networking lab, and then we're going to talk about backup and recovery. The first thing I'm going to do, though, when we get back at 1:05, is I'm going to talk about some practice exams, and we're going to take some practice exam questions. So just know when you get back, we're going to be doing practice exams. No need, Calvin. No need for that. The fact that you would pass would actually be reward enough, right? Just because you've put the work in and done all the work. All I've done is given you the pieces, right? So I appreciate that, though. Although if I ever hold a class face to face again, I will not underappreciate the value of passing out stickers. I used to pass out stickers all the time, and I just really used to enjoy it. Now I have all these piles of stickers over here, from like anime stickers to superhero stickers. I don't get to pass out stickers anymore. Kind of miss it. People like, what do you miss from COVID coming in and traveling? I miss passing out stickers. That's what I miss. Yeah, Calvin, 2 months to review is probably pretty good. That's 8 weeks at least. That's a good idea, actually, just to throw that out there.
And compared to this class, how much do you think the Tech Excellence program would prepare you for the certification we're going for right now, the Associates Architect?
That class will not prepare you at all for the architecting class. Tech Excellence won't. Yeah, because it's more operations focused.
Yeah, would it help with the sysops?
It will help with sysops. It'll give you 60 to 80% there for the sysops associates one, but it won't do architecting at all.
Okay.
Oh, Calvin, sorry to answer your question. Do I teach the professional essay class? I do. I actually just finished teaching one last week before. But I don't have any coming up for the remainder of the year. So, all right, I'm going to step out. So the session's going to stay up, obviously. But we'll see you in just about an hour and 10 minutes. So I'll see you at 1:05 p.m. We're going to continue with exam prep. Okay. See you in a bit.
Okay, thank you.
Welcome back, everybody. Let's see. To answer a question that popped up, do you suggest the professional class right after passing this exam? Actually, I would recommend that you actually take some time to work either the study guide or the ramp up guide for the next level, right? If you're gonna go for the Arctic Pro, it just has that short section in it, but it's a good primer. And then from there, I would definitely squeeze in the class if you can and do the exam readiness kind of online section, but it's all in that ramp up guide that I shared with you yesterday. So, oh, funny. Okay. So Calvin, if you follow the ramp up guide, it actually takes you from associates all the way to pro. I would probably do the classes in there, the like little trainings in there first before I took the class. But then you could go, you could go straight to the class. The class is very deep, and it's also a 3-day class, so it's intense as well. Okay, so let's talk about some practice exams. Probably not a bad idea, Calvin. Maria, sorry. You can go back to the labs at any point in time. The labs are available to you until February 2nd, so feel free. Absolutely. Reminder that when we do these exams, we are asking you to do review mode, not timed mode, which is where it just took me, right? So make sure you do the review mode exams. The other ones I would avoid if at all possible. All right, so let's run through some practice questions. We're going to do that for about 30 minutes before we roll back into the rest of the topics. Before I do this, I meant to ask, did anyone have any questions about the serverless, the SQS, the SNS setups that we just did for the lab before lunch? Okay. All right. Well, let's talk about this then. Okay, so here we are. We got a global news network. They have a CloudFront distribution in front of their web application. They notice that the application's origin server is being hit for each request instead of actually using the CloudFront edge locations, which serve the cached objects. This issue occurs even for commonly requested objects. What could the possible problem be? So in order for CloudFront to not cache objects, you have to tell it not to cache any objects, right? I know this sounds weird. So there's a couple of different ways to tell it not to cache objects, right? One of the things is the file sizes of the cached objects are too large for CloudFront to handle. I actually don't know what CloudFront's maximum file size limit is, but I've done video files that have been gigs in size, so I don't know that CloudFront actually has a limit. I'm sure it does, but I don't know what it is, because I think I've uploaded like 10 gigabyte video files before, and I think it's worked fine. And then having two origins isn't going to make a difference. But if you know that about the cache control max age directive, I suspect that's probably it. Because if you set that to 0, it's not going to cache anything. It's just going to act as a dynamic kind of like network accelerated path. It's not going to cache anything. So, it might be slightly faster, but it's going to act like everything's dynamic content. So suspected that was the answer. Just to say this, it doesn't say what the CloudFront max size is. I wish it would be. Yeah, and this one's technically incorrect because you can't actually set two origins. You can set a primary origin and a failover origin and the criteria for failover, but yeah, that's it. So the main thing is that you can actually set it for up to an hour for expiration or up to 0 seconds for web distributions, right? So so if the cache control directive has a low value, it means it's going to continually not cache items. So that's the main thing to know. All right, number 2, website hosted on ECS containers loads slowly during peak traffic, which affects its availability. The container instances are behind an ALB, and CloudWatch alarms are configured to send notifications to the ops team if there's a problem, so they can scale it out if need be. Architect needs to create an automatic scaling solution when such problems occur. How do you do that, right? So let's see what's happening here. So it looks like this first part is actually about either scaling out the cluster or scaling out the service. So there's 2 options here, right? So two sets of answers. So we know automatically that there's 2 sets of answers. One that's about the cluster and one's about the service, right? So these 3 are about the service. This is about the cluster. So it sounds like we're going to scale out the cluster, which is the worker nodes, and we might scale out the service itself, also known as the task, right? So what's interesting here is that if we're going to scale out the cluster, then we probably care about the cluster's CPU utilization, like if in general it's too high. And if we're going to talk about the service, then it might be because the service is too high. I don't know that we care about the load balancer, because the problem is saying that we're having an issue with the containers, right? So they're loading slowly. So for example, it looks like we really want to focus on the target group, like maybe that CPU utilization is too high, or either the cluster CPU utilization too high. Quite frankly, they're kind of the same thing, but we're really actually more interested in the containers themselves. So I'm going to take a guess here and say it's probably going to be the target group CPU utilization. This question's a little soft, right? And then the auto scaling policy for the ECS service, well, I don't really care about the ALB that much. I'm going to say that when the service's memory utilization is too high, just in case, right? And let's see, because, this question is kind of soft as far as its distinction, so it's hard to figure out kind of exactly what's going on. Okay, so in this case, this was interesting. It wasn't about the target group CPU utilization, and mainly because I don't think you can set the scaling policy against the target group's entire CPU utilization. I think you can actually either do the service or the cluster, right? So in this particular case, they're going to scale up the cluster if the cluster gets too high. That's where I was headed originally, and I kind of changed my mind, right? But if we look down here, right, the following metrics are available for a service: CPU utilization, memory utilization, and the number of requests completed per target, right? If we look at the cluster for like the actual like instances, we've got all the standard EC2 options, right? Network in, network out, disk writes, disk reads, CPU utilization. Notice that memory pressure is not by default available because actually, I don't remember why that was. There was a reason why memory is not available. I think they focus more on memory when it comes to the service and not actually on the box itself. You can add that as a custom metric though. So let's look at why the target group utilization is not high. Scaling doesn't support this metric for load balancers. Okay, that's why. So that would be needing to know what the load balancer will support. Hitting the ALB high CPU utilization is, you definitely can't track that, so that's not going to make sense anyway. I don't even think you can see that. And then the endpoint becomes unreachable. That's a high availability problem, not a performance problem. So we wouldn't include that. But we were close. By the way, there's no penalty for guessing on these exams. Okay. So this highlights the things that you need to know about managing an ECS cluster, and what you can know about the ECS service itself. All right, next one. SA is working for a weather station in Asia that's going to be migrated to AWS. They have a weather monitoring system. Since the monitoring system requires no network latency and high network throughput, the architect decided to launch the EC2 instance to a new cluster placement group. Not a spread placement group, right? But a cluster placement group. Not a partition placement group, right? They decided to do this instead. So the system was working fine for a couple of weeks. However, when they try to add new instances to a placement group, they receive an insufficient capacity error, when you launch a cluster group, they all run on one what? When you launch a bunch of virtual machines that are in a cluster group, what do they all run on together? That's right, where they actually run on the same host, right? They're trying to get all the virtual machines on the same host. Now, there might be other people, other accounts on that host that you can't see, but when you launch those 10 instances, they're going to try and put them all in the same physical box. If someone else comes along and adds their boxes to that physical host, you won't be able to add additional capacity, and it's telling you have insufficient capacity. So what has to happen is that you're basically going to have to like relaunch the placement group, right? So you're not going to verify all the instance size and types run again. You're not going to submit a capacity increase because that's not going to help you. So you're either going to stop and restart the instances in the placement group and then try to launch again, right? That's not going to help because restarting the existing group probably isn't going to get you what you want. You have to launch them like all at the same time, right? So you're going to create another placement group and it says launch the instances in a new group. Well, if you're going to create another instance and you're going to like put the new instances there, they're going to be in a separate placement group. So that's probably not going to work. What you really want to do is you could stop and restart the existing instances. That will move them to another physical host, and hopefully that host has space. If that doesn't work, you're actually going to have to stop and delete all of the instances in the group and relaunch them with the new number. So let's check and see, because that's how placement groups typically work, right? And so in this particular case, stopping and restarting will give you an increased chance of doing that launch, but it's not a guarantee. The only way to guarantee that you can actually launch with the new size of instance, so let's say you go from 10 to 15, is to delete the existing placement group and start another one with 15 boxes. So that's not an option, obviously, in this case. So this is the right answer because it'll help you figure it out. Remember that this was a cluster placement group. Notice this is a partition placement group, so I don't know why they have this picture here, but ignore that picture because these are all going to run on the same physical box. So that's the wrong picture for that. Okay, this one I'm just going to let you answer. I'm not going to digest it, okay? So we got a multinational manufacturing company, multiple accounts, separate departments. There's a requirement to ensure that certain access to service and actions is controlled properly to comply with the security policy of the company. As an SA, which is the most suitable way to set up a multi-account AWS environment of the company? Yeah, what is the service that's used to create a multiple account setup that also allows you to control the services in question? So really, if it said control tower or landing zone, that could be a possible option, but both of those are just like wizards to organizations. SCPs, which are service control policies. So that's definitely the answer. So good. Here's a reference to organizations, cheat sheets, IAM policies versus SCPs, comparison. There's a big comparison of AWS services. Good. All right, they want to put a network monitoring system in AWS. The architect launches an EC2 instance to host the monitoring system and use CloudWatch to monitor, store, and access the log files of the instance. Which of the following provides an automated way to send log data to CloudWatch logs from the EC2 instance? So this is similar to a question we had yesterday. How do we automatically send logs to CloudWatch logs? So to my knowledge, seeing some answers here, which are good, they're right on the mark. CloudWatch logs agent. There is no processing library for CloudTrail. There's no log file validation for CloudTrail, not that I'm aware of. It really is just a CloudWatch logs agent is the thing, right? Good. Remember, there's an SSM agent, there's a CloudWatch metrics agent, also known as the CloudWatch agent, and there's the CloudWatch logs agent, which gather logs. So Amazon in general is not going to install and activate this stuff for you because they don't want to cross into your operating system. You have to ask for this to be installed. Okay. Okay. Companies launching an application that tracks the coordinates of delivery trucks in the country. Coordinates are transmitted from delivery trucks every 5 seconds. You need a architecture that will enable real-time processing of these coordinates from multiple consumers. The aggregated data will be analyzed in a separate recording application. What is the service that we just talked about that is used for real-time inside of AWS? There can be only one. Well, there's actually two, but in this case, only one. Good. So I see a lot of C's here. That's perfect. So if we check, Kinesis should be the answer, right? Remember, Kinesis's job is to do real-time collection processing and possibly analytics, right? So Kinesis is really the only valid answer based on the services. All right. Tech companies have an issue when they try to connect to newly created EC2 instances using RDP. Upon checking, the SA has verified the instance has a public IP and the internet gateway and route tables are in place. What else can you check other than base networking connectivity if you want to verify that you can connect to an instance? And if they're using RDP, what port are they going to run on? Good. All right, so adjust the security group for 3389. The 3389 is the RDP port, so that's what they're connecting to. If they were using SSH, it would be port 22, but they're not. They're definitely using, oh, my horn broke. They're definitely using 389 for that. All right. SA needs to launch a web application that will be served globally using CloudFront. The application is hosted in an EC2 instance, which will be configured as the origin server to process and serve dynamic content to its users. Which of the following provides high availability for the application? So which of these is going to provide redundancy for the application? So I see that B was the vote, right? And actually, this is actually going to work because it doesn't. The only thing that threw me off is that they didn't specify a load balancer. But I mean, you could point between the two EC2 instances. That wouldn't necessarily be a showstopper. I was just kind of shocked that's the way they wanted to describe it or talk about it. I would have thought possibly the auto-scaling group of EC2 instances and configured to be part of the origin group. But really, as far as the minimum thing you need for high availability, it's 2 instances. You don't need an auto-scaling group. So that's what I would have guessed, actually. And you did as well. But let's see why, technically. Oh, I see what they were going for there. They were setting up a primary and a secondary origin. That makes sense. So for HA, you needed a primary and secondary origin, which is why that wouldn't work. S3 doesn't work because it won't serve dynamic content. It only serves static content. Lambda to Edge is for serverless computing, so that's not applicable here. But that's why autoscaling wouldn't work, is that you could actually set autoscaling has one of the origins, but if you want high availability, you need 2 origins, which would mean 2 separate systems, in this case, 2 separate EC2 instances. So that clarifies that. A company has several unencrypted EBS snapshots in their VPC. The SA has to ensure that all new EBS restored volumes from these snapshots are automatically encrypted. So what do you do? Like, what do you touch here to make this happen? Is there an EBS encryption by default feature for specific volumes? Is there a by default feature for the region? Do you have to launch the new volumes and specify the symmetric key? Or do you have to use the volumes and specify an asymmetric key? What kind of keys do we use actually for hard drive encryption? This one, I gotta tell you, I don't know that I would get this one right. Only because I know that we use symmetric keys and we don't use asymmetric keys, so I'm kind of torn between B. But the thing that's throwing me off is that I don't think there is an encryption by default feature. But I mean, man, I've been wrong before about this. They add new features all the time, right? So this one's throwing me off a little bit because I would have technically actually guessed B because it was a symmetric key and then launching new EBS volumes. I didn't think there was an encryption by default feature, but let's find out, right? So let's see. I see a couple of people at D. I got 2A, so let's try A as the answer and let's see what happens. So, oh, look at that. There is an encryption by default feature, and I suspected it would be for the region and not for the specific volumes if it did exist, because I don't think they would do that. But yeah, so in this case, this is the new feature that I actually didn't know about, is that you can actually go in and set it apparently for the entire zone and say, look, by default for EC2 settings, I want you to set the account so that all volumes are encrypted by default. I didn't know that, actually. So that's good. Notice it says that it only applies to Stockholm, which is where they're at. That is good to know, actually. Yeah, EBS, by the way, doesn't support asymmetric, so I knew that wasn't the answer. Oh, why wasn't symmetric keys the answer? Although it will enable subscription. This is manual. Yep, that's true. It is manual. And they did have a requirement, by the way, up here, right? Automatically encrypted. So honestly, it would have to be a setting, wouldn't it? Right? If we had peeled it back correctly, automatically would require it actually to be either A or D. And I'm pretty sure it wasn't A because you wouldn't do it for specific regions. It'd have to be for the entire thing. Okay, good to know. All right, let's take a look at this one. So a web application is hosted on a fleet of instances in an autoscaling group, and there's a couple of Lambda functions for ad hoc processing. Whenever you release updates to your application, there are inconsistencies where some resources are not updated properly. You need a way to group the resources together and deploy new versions of your code with minimal downtime. Okay, so you've got EC2 instances with a couple of Lambda functions. So how do you force code deploy, for example, to structure your deployments so that you can deploy in a consistent manner? That's really the question, right? Because it's not going to be CloudFormation. It's not going to be code commit, which is hosting code. And OpsWorks is used for configuration management. So even if you just knew the services, most likely the answer is A, right? Code deploy with automated code deployments, and you're going to use deployment groups to kind of group things together. That's just a straight up like knowing the services. If you're deploying applications, you have to use code deploy for the most part. CloudFormation can do some deployments, but it's not the tool of choice, right? It's mainly for provisioning, not for application deployment. So notice there's Beanstalk versus CloudFormation versus OpsWorks versus code deploy. So John must have gotten this question a lot, and he has a cheat sheet for it. All right, this one's for you. Deployed a web application to an EC2 instance has a variety of photo effects added for the users. The application will put generated photos to an S3 bucket by sending a put request to the S3 API. What is the best option for this scenario, considering that you have to have API credentials to send a request to S3? How are you going to grant this application access to S3? That's the question. The answer, if Amazon ever asks you to grant permissions to an application and that application is running on AWS, is always roles. It's always a role. If it's running off on-prem or off cloud, then you might need to use a user ID with a like secret access key. But even then, you can, in some cases, you can use service accounts. But roles are pretty much for any temporary access, especially for AWS services. Now, I say that, which should be totally wrong. Forrester, you're wrong. Okay. Let's check this real quick. No. The rest of these are kind of like from a security perspective, kind of dumb. Like they're ridiculous. All right. Company creates a VPC with a single subnet, then launches some on-demand instances into the subnet. You've attached an internet gateway to the VPC and verified that the EC2 instance has a public IP address. The main route table of the VPC is shown below. The instance still cannot reach the internet. What is the problem? What is missing from this route table? What's missing is what's called a default route. In other words, if traffic isn't 10.0.0.0/27, and where do I send it? Now, right now, it just goes nowhere. It just dies, right? But you're right. Like everyone's kind of like hit it. There's no route table for the internet gateway. So we've got an add what's called a default route. That 0.0.0.0/0 means all traffic, that anything that matches this, send it to the internet gateway. So if it matches the 10 traffic, it's going to go there first. Otherwise, it's going to dump everything to the internet gateway based on adding this entry. So that should be the answer. All right, last one. Then we're going to switch gears. A company has an application architecture that stores both the access key and the secret access key in a plain text file on a custom AMI. No. The EC2 instances which are created using this AMI are using the stored access key to connect to a DynamoDB table. What would you do to actually make this architecture more secure? It literally is a variant of the question that we just talked about. Yeah, so first of all, you remove the stored keys, create a new role, and assign it to the EC2 instances. That is dead on. Good. All right, let's do one more. Let's sink it in. An application is using a Lambda function to process complex financial data that runs for 15 minutes on average. Most invocations were successful. However, you notice there's a few terminated throughout the day, what caused a failure in the application. What is the problem with an average 15-minute execution time for Lambda? What's the issue? Good, I see you all posted A, right? That's right. It means it can go over 15 minutes. The maximum execution time is 900 seconds for Lambda. So that's the problem. Good. Okay, one more. I know. I'm greedy. I know we need to switch, but whatever. All right, software development company needs to connect its on-premise infrastructure to the cloud. We literally just talked about this morning. which of the services will allow you to connect your data center to Amazon either over the internet or through a dedicated cable? You got 2 of them. Which ones? So direct connect and VPN connection. Let's see. I'm just kidding. That's it. So so direct connect and VPN, and they don't call it I mean, it is IPsec VPN, don't get me wrong. It's not GRE VPN, but whatever. Usually just refer to it as a VPN connection. So here, what they're doing is they're just saying, hey, these are the 2 possibilities. Okay. All right. So that should give you a feel that once you get past the study guide that we talked about before, and you've done all the white papers and everything in that study guide, then you switch over to doing practice labs, and you're supposed to do these until you get 90% on 2 sets of these questions. It needs to be the same set of questions, right? Once you get a 90% on 2 sets of these questions, if you've touched AWS before and done a production workload, you're probably ready to take the exam. If you haven't, you probably want to do a 3rd set of questions and get 90% on that, and then you're ready to take the exam. Okay, so keep noticing that my camera keeps changing color based on where my hand is at. That's really strange, actually. So just be aware that you're going to want to take probably 2 or 3 of these sets of questions until you can get a 90% plus consistently on them, and then move on to the next one. Get 3 of those under your belt, you're ready to go. Okay. So with the study guide we've provided you, plus access to these practice questions, plus all the stuff in there as far as the labs and white papers, you should have a path to study for the exam. It will take you on average about 40 hours of additional study after the class ends to achieve the level that you're looking for to pass the exam. I say on average, you can go faster, okay? Are there any questions about that process that you're going to follow to get ready to pass the exam?
I just have a question about these practice exams.
That's
Is
cool.
that something we'll get access to eventually or something? Because I've created the dojo account or whatever, but at the moment I cannot access any of the practice exams.
So it looks like what they did is they changed the process slightly. You should have gotten an email that has the license key inside of it. I know that at least one other person has gotten it. So
Okay. I
yeah.
did get an email with a license key a day or 2 ago.
Yeah, so
that's for practice exams. Okay.
Yeah, so what you're going to do is you're going to go and purchase the exam, and then there's going to be a space to enter the license key. The instructions should be in there, and then it's going to let you register. So they changed it slightly on me, and they just told me actually yesterday afternoon that you now are all getting a license key, and so now you're going to register your license keys, and so that way you can just do it when you're ready.
All right, I got it. Thank you.
Yeah. So, all right, so you should have everything there. The links are all inside the study guide that was sent to you, so you should have access to that. And of course, any of the download links that we talked about, both in any of the practice sessions, you can download those as well. After this class closes, by the way, GoToMeeting is going to send you access to these links all over again. So if you did, for somehow you missed it either in the posting of the chat or you didn't download it the other day when we were reviewing it, just know that GoToMeeting is going to send this to you all again. And if you run into any issues at all, you've got 2 options. You can send an email out to support@webhsolutions.com, or just talk to me directly. Just send me a thing. It might take me a day to get back to you because I might be teaching, but I'll respond to you as soon as I see your email, right? And I am going to send a post follow-up email that's going to have everything aggregated. So don't worry, you're going to get over communicated to as far as like, do you have these links? Where are they at? What's included? What's not included? We're going to make sure that you have it, okay? So you're going to get multiple emails with all this information in it just to make sure you got it. Maria, you were asking about vouchers for the test.
Yeah, does it come with a voucher for free?
I don't think it comes with a voucher for the test, right? I don't think that you get it unless if it was explicitly stated in the description for the class. I don't think you got a voucher.
In my email that had the coupon code for the practice exams, it did say something at the bottom about double shot test vouchers.
There you go.
For the exam. It didn't give any codes or anything, so I guess those are coming later or something.
Those are only basically, you can only get those after you complete the class, because Amazon won't allow us, like won't send them to you until after the class closes.
Okay.
So you do get it, if you do get a double shot voucher, that means you have 2 attempts to actually take it. That's an unusual circumstance, by the way. Amazon usually only gives out 1-shot vouchers. The fact that they're giving out 2s, especially for the associate's exam, that is an extreme rarity. I haven't seen that in over a year. So that's great. So of course you're going to pass on the first time, but you know, that happens as well. So Maria, everything will be sent to you after we finish the last class, right? So you're going to get the certificate of completion. You're going to get all the links, right? You're going to get the, in this case, I didn't know about this one, but you're going to get the voucher. So don't worry, you're going to get everything like within about 3 to 5 business days after the class closes.
Okay, thank you.
Yeah. Okay. And of course, just to say this, if you're missing anything, if something happens, something falls through the cracks, just email me or email support, right? Either one. We'll figure out what it is that you need or don't have. I will say it will take about 3 to 5 business days, at least for the certificate of completion. The vouchers tend to go out, you know, pretty quickly. But again, that all comes from Amazon. So, you know, it's all part of the process. So just let us know if you don't see it. I would say if you don't see it by, I would say like Wednesday of next week, just email me. We'll make sure that gets done. All right. By the way, it looked like when I looked at it last that the second video was up there for day 2. So once we finish today, we'll put the other videos up. The other video. And I'll add in the certification class video in here that you can watch at your leisure. These things will stay up indefinitely, by the way. Unless YouTube decides to change something, which they did do back in 2018, 2019, it broke a bunch of links. For the most part, it was mainly unlisted links is what it broke. These are going to stay up for a long time. This will be pretty out of date, probably within a year, just so you're aware. So after that point in time, there's going to be a lot of changes. So, all right.
One question about the test vouchers. Does that give you 2 free attempts, or is the first attempt just like discounted and then it's a free retake, or how?
No,
I've never...
they're both free.
Cool.
Yeah. When they say they're double shot, it means 2 free attempts, definitely. Be aware that there is a 2-week cooldown period if like you take the exam and you don't pass. I think you have to wait 2 weeks before you can go forward at that point in time. Okay. It is 1:43. And here is what we're going to be doing for the rest of the day. We're about to talk about edge services, and then we're going to do a lab. That's going to take about 90 minutes to do. And then we're going to spend about 45 minutes. So we have about maybe a little bit more than 2 hours kind of left, which that'll put us at around 3:43. I am then going to just talk about closing out the class, next steps, reinforce some pieces for you. And then what's going to happen is I'm going to put the evaluation in your hands, which you get to talk about what you need to improve in the material, you know, things that feedback from me. You know, all we ask is that you be respectful. If you start cursing, we probably won't read your feedback, just so you know. But if you're like, hey, you know, Michael needs to do this, or the class really could use this, or I'd really like to see a class on this, all of that would work fine. So once that's done, that'll be the official close of class. All the video recording will stop, and you can come, go, stay, or do whatever at that point in time. I'm going to open up the Capstone Labs. I'm going to be with you at least until 6 o'clock if you want that, or you can just bug out if you want to and leave for the day. That's all based on whatever you're looking for. The Capstone Lab is a 2 or 3 hour lab. So after we cover Edge, after we cover backup and recovery, the remainder of the 2 or 3 hours, remainder of the day is going to be focused on that Capstone Lab. And I just like to give people the option, because a lot of people decide that they're going to do it later, like the next day when they have less pressure or a little fresher, instead of tackling it at the end of the day. So it's cool that they have a Capstone Lab, and I'm going to show you where the answers are, the step-by-step instructions are for the Capstone Lab. But it tends to wear people out. So I'm just giving you the option. But regardless, I'm going to be here until 6 o'clock supporting you until, you know, whenever you decide that you're done. Okay? So that's going to be the end of the day. So that all being said, let's talk about let's talk about Edge, right? First of all, you may not know this, so let's just say it. Let's just pretend that I asked you, right? What percentage of your workloads require ultra low latency devices and end users? Anybody know the answer to that? All of them? None of them? Right? Yeah. I would say, especially if you're serving the military, it's probably definitely going to be closer to 100%. If you're doing some other role, that might be 0 actually. Now, I will tell you, obviously, the abandonment rate when a web page takes like 2 or 3 seconds to load is super high, and it gets even higher as you get younger in generations. So, in general, people are going to want at least single-second load times for their web pages. Typically, they want it faster. So, just keep that in mind. So let's talk about edge services. It might even be worth pre-warming the labs for edge services. Just making sure everything's good. Okay, so we're all good here. All right, excellent. Okay, so feedback. We have users across the globe. Why are you using California? Anyway, moving on. So we need to drive low latency, and we need to protect against distributed denial of service attacks. How do we protect and also deliver performance? How do we do that? And what if I have web applications that need some kind of specialized web firewall in front of them? How do I accomplish that? All right, so here's the thought. One, we are going to talk about Global Accelerator. I think I mentioned this before. But the main joy here is how do we basically provide protection from the edge back to the core? And then if we want to actually put something in our data centers that AWS can manage for us, can AWS provide managed hardware that links in tightly with our account? And the answer, of course, is yes. So how do I reduce latency? How do I run AWS services in my data center? What if I want regional failover and regional distribution? What if I want to do that? How do I accomplish that? Right? How can I protect public-facing applications? And how can I improve the performance of my applications overall? Right? And so we're going to talk about some edge fundamentals, the CloudFront service, Global Accelerator, the two services that really make up, well, two services, the one service that makes up distributed denial of service protection, and then how to run services, AWS services in your data center via outposts. Now, edge fundamentals means basically, how do we provide the lowest latency possible the world over? What is the edge? Well, the regions are the core, and any other location, whether it's local zones, outposts, wavelength zones, or edge locations, those are all outside of the core. That's the edge. Now, edge locations, like the regional edge locations, do run in every major city that they have a region in. But the catch here is that they run in every single place that there is a major ISP. So this map is somewhat deceptive because it shows you where the regions are, but what it doesn't show you is that in pretty much everywhere there's a major ISP in almost every major city in the world, Amazon has a rack of servers that is sitting there acting as a cache. And the use case is exactly what we showed you before. I have somebody in China trying to get to my system in Brazil, and I got customers talking to this edge location. How do I facilitate their consumption of these video files? So what service can provide us with the content delivery network that we need? Well, this is what CloudFront is used for, right? So here you see the smattering of regions that are kind of pending. And then you've got all these like edge locations that are scattered all over. But I just want to say this map is actually out of date, and there are a lot of points of presence that are missing. Like there's like 4 or 5 alone in South America that are not listed here. So it's not 230 points of presence. My last thing I saw was like over 300. So this is a little behind as far as like where all the servers are. There's also 2 more in Africa as well. So like this is a little out of date. Now, what this allows you to do if you decide to use CloudFront is that you hit these caching servers instead of going all the way back to the source. That's also known as an origin. So here, what's happening is that without caching, you're going straight back to the source. With caching, instead, what's happening is that you're hitting the closest server, of which there could be 300 of them. That server is going to act as a proxy to go back to the origin or the source on your behalf. And it is going to operate over Amazon's high-speed backbone. Now, you can have multiple origins. So you can have a primary origin and a secondary origin act as failover for CloudFront. But CloudFront, imagine, has these servers that are all over the world. And these are the things that you're hitting. You're hitting those servers first and then getting back to the source. Whoops. Now, CloudFront is a content delivery network. This is not unique to AWS. Cloudflare, Fastly, Akamai, those are all content delivery networks. They do integrate with both the Web Application Firewall, which is what WAF is, and Shield, which is a distributed denial of service system. It supports static or dynamic content and has a ton of built-in security features like geofencing, as an example. Now, it will cache. So someone comes in and says, I want a video file. If it has the video file and it's fresh, it's going to give the user a video file. If it doesn't have the video file, it's going to go back to the origin, in this case an S3 bucket, get the video file, put it in the cache, and then feed it out to the user, right? So data is transferred to the end user as a result. Now, when you configure CloudFront, you know, this 4-step process of someone's asked you for something, you go back to the source responds, and then you respond to the user. You can configure all 4 of these stages. What you do when someone asks you for something, what CloudFront does when it asks for the origin, what it does when the origin responds, and modify the response that you send back to the client. So 1, 2, 3, and 4, those 4 communication stages are all controllable. Now, configuring CloudFront is just as common as like you need to create a distribution. They're going to give you a DNS name. You need to put that DNS name behind your URL. So if it's www.amazon.com and you want to use CloudFront, you need to resolve to the CloudFront distribution. And then you're going to do some configuration. But all of that caching and stuff happens for you automatically. You don't have to do anything. CloudFront just does it for you. Now, CloudFront has a number of possibilities of origins. You can use an EC2 instance. You can use a custom origin. You can actually originate outside of Amazon's networks. So you don't have to stick with AWS services here. You can just use CloudFront to front other on-premise services. You can do things like force SSL, do pre-signed URLs, do pattern matching, like you can do like transformations. You can set the time to live. So if you want a video file to not be any older than 30 seconds, you can do that as well. So you get to control exactly how each of the 4 stages of the life cycle, how it all behaves. Here's an example of CloudFront being in front of an ELB and in front of an S3 bucket. If someone hits the URL and they're asking for a JPEG, it's going to come from the S3 bucket. If someone asks for any HTML, it's going to come from the load balancers. So this is an example of how CloudFront can pattern match against whatever regex you want to use to match certain file types and certain pathings and send them to different kind of origins in this case. So CloudFront is a content delivery network that's going to accelerate delivery and reduce latency for your users. Again, this works off of the entire global 300 server, 300 location edge locations. And so hopefully there's an edge location somewhere closer to where you're trying to feed out of, right? Now, other options here are like Global Accelerator. So if CloudFront is a content delivery network, if you need like a load balancer that operates more at a like global level instead of just a regional level, you know, how do you operate your performance for latency sensitive networks? You've got this kind of like, it's almost like a redirector. It's not really just a router. It's not really just a load balancer, right? In a sense, it basically gives you an IP address, and so it can reduce the number of network hops it's going to take for you to get between AWS and your clients. So for example, with Global Accelerator, the IP address they hit will then redirect them to the closest data center that you have, and it will basically monitor the health of those endpoints and route traffic to the closest healthy endpoint. So it does use a static IP address as a fixed entry into the AWS hosted application, and then it basically then routes it to whatever availability zone or region you need, right? This is going to improve the speed, the latency, and the availability of your application. So this is going to do performance and it's going to do availability. Because for example, if you're routing it and all of a sudden, you know, one of these sites goes down, well, first of all, the user's going to go to the closest location. So that's going to give the user the best experience. But if all of a sudden one of the locations goes down, the endpoint's actually going to redirect them to the closest one that can still serve out traffic. So in a sense, it really is kind of a global load balancer between regions, improving high availability and performance. Now, one of the differences here is that CloudFront is going to accelerate delivery of web-enabled objects. Global Accelerator, since it operates at an IP address level, is going to do layer 4, right? So it's going to do any protocol running over TCP or UDP, including web traffic. But CloudFront is only going to support web traffic. So this is layer 7 only, right? CloudFront is DNS-based, so it comes with all the headaches that DNS-based routing functions as. Global Accelerator is IP-based routing, and so it operates very differently. Okay, so think of Global Accelerator has a global load balancer that's IP-based. Think of CloudFront has a content delivery network that only really serves web objects. Questions thus far? Okay. So how do we protect against distributed denial of service attacks? How do we stop like malicious users from creating a bunch of fake personas and just attacking our accounts with fake traffic? How do we stop that? Otherwise known as bots, right? So these attacks happen at different layers. So the first layer that these attacks usually happen at is that someone's going to try and break the IP stack. That's the first thing they're going to try. Now, Shield standard is included with every single AWS account by default. That will protect you against layer 4 and layer 3 attacks because Amazon is first and foremost a security company. That was the biggest argument about using Amazon way back in 2006 is that they're never going to do security as well as I can. And now, arguably, AWS is doing security probably better than most of us. Not everybody, but most of us. But what happens about layer like 6 or 7 attacks? Like, how does that get mitigated, right? Well, this is where WAF comes in. So WAF operates at layer 7, right? Good, Ryan, you're already there, right? So WAF stands for Web Application Firewall. This is not a concept unique to Amazon. They just happen to have a service called it. There are tons of web application firewalls out there. But what this does is that this filters malicious traffic out of your system. So for example, if you allow SQL injection because you haven't parameterized or sanitized your inputs, also known as little Bobby drop tables, if you've never seen XKCD, right? But like some people are running applications where if you put drop production table on there, and you have to know the name of the table, obviously, it will actually drop or modify the like table, or like first you can list the table and then you can drop it, which is the same as deleting it, right? So just know that like WAFs protect against like cross-site scripting, SQL injection, right? And it'll protect CloudFront, ALBs, API gateways, AppSync. It'll protect a lot of services. And you get to either use AWS managed rules or write your own rules for WAF. Now, these rules that we use, they usually contain things like what IP addresses, what is the regular expression we're going to restrict, is it all web traffic, are we filtering for SQL statements? Just so you know, AWS has managed rules that you can use. You can also buy rules in the AWS marketplace. So they provide managed rule groups. By the way, some of those managed rule groups are things like known bad actors. So if hackers are operating out of a certain IP range, they'll automatically block that for you. You might lose some clients, but frankly, that's probably not the case since most of that's dark web stuff, right? So you can control traffic by either preventing, filtering traffic, matching against known bad patterns that are traffic you want to filter, or known good patterns, by the way. And you can actually combine rules together that says, look, if the user is in this country and they're coming from this IP range, we're out. Block that traffic. So you can actually nest rule statements together using the logical operators. Now, if you are running an enterprise and you have to write these rules, and because the company has minimums, and you got to push these out across a bunch of WAFs, a bunch of web application firewalls, we're going to use the firewall manager. So this is another service, not the WAF service, right? This is a new service that will allow you to push rules to both the network firewall, which is also another service that Amazon offers that runs a network firewall, and WAF, and you can actually push security group rules, and you can push shield changes as well, right? So it enables a central minimum baseline of security, and you can consistently enforce the protections across your entire account. So this is useful if you have a large number of accounts and resources. People are launching new stuff all the time, and you need visibility into your organization-wide threats. Firewall Manager works with organizations, so you have to have organizations enable to manage your rules. So just something to be aware of. Here, by the way, is everything stacked up together. Okay? You got Shield sitting in front of everything. And then what's happening is it's going to route into DNS, and it might go through a WAF to hit CloudFront, to hit an Elastic Load Balancer. That WAF, by the way, could sit in front of API Gateway. And all these rules are going to be managed by the Firewall Manager. So I don't know why they're showing Route 53 go directly to the API Gateway. They could have the API Gateway kind of back a little bit more. There is a white paper that called Best Practices for DDoS Resiliency, AWS Best Practices for DDoS Resiliency, that covers a lot of this in detail. Okay, last but not least, here we are. Let's talk about Outpost. Does anyone have any questions about CloudFront has a content delivery network, Global Accelerator has a global kind of redirector, router, and load balancer, or either Shield or WAF has protection tools for your core and edge networks? All right. So Outposts is what you want to use when you want to host AWS services in your data center. So here's the deal. Basically, you start the whole process. They assess your data center. They ask if you have power and cooling. You get the size of the outpost that you want. And what you do is it does this. They stick a rack basically in your data center. To fulfill this, you got to schedule a date and time. You got a bunch of checklists. Those checklists have to be checked off. A team is going to roll everything to the identified location. They're going to help you establish power, cooling, and network connectivity to the rack over the uplink you provide. And then they're going to make sure they can talk to AWS and that you can see it in your account before they walk out the door. So that's it. That one's not super complicated. Here are the services, by the way, you can run on that rack. I don't think anything's missing here. EC2, ECS, and EKS. I don't think you can run Lambda, but they might have changed that. I know that was in the works. Relational database service, S3, EBS, EMR. Most people use this for ECS, EKS, and for EC2. I don't see a lot of people using it for RDS or EMR. And S3 as well. That's it. You get a rack, it gets installed. It's got some services on it. You do have to manage it locally, so you have to like add endpoints into your like command line, for example. But it actually can also show up inside your console if you want. All right, let's do some knowledge check. What are the potential benefits of implementing a CloudFront distribution? Good. Let's see. So first of all, one thing to note is that definitely reducing latency is going to be key, right? But I just want to say this is that you don't get automatic redundancy because remember those objects expire. So while it does add a caching layer, right, which you could argue that is redundancy, but it's not long-term redundancy, it's just short-lived redundancy. Because if the origin goes away, you're going to lose access. So that's not considered a permanent solution. So AWS isn't going to consider that permanent for redundancy. What it will do, though, is that because it has increased security filters and geofencing and other things for CloudFront, plus it will actually prevent distributed denial of service attacks because it has to overwhelm the CloudFront servers, of which there's a bunch of them. That's going to be increased application security. But redundancy is not permanent, so it's not going to be part of it. Okay, which of the following services offers distributed denial of service protection? Select two. Shield is definitely one. What's the other security service here? Good. D&E, right? Perfect. That's it. One other question for you. What's the name of the service that allows you to distribute firewall rules across all of the WAFs, all of the security groups inside your organization, including the network firewalls, which we didn't talk about as a service? Yeah, good. Don't forget Firewall Manager. I saw at least one question the last time I took the associate's exam on Firewall Manager. And it just asked that question. It was like, what do you use if you want to globally distribute rules, blah, 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 blah. Now you know. Okay, that's it. Let's talk about the lab, unless there's any questions at all. Okay. So let's configure a CloudFront distribution with an Amazon S3 origin. Let's do that. So what we're going to do here is that we're going to actually explore an existing distribution. We're going to create an S3 bucket. We're going to configure the bucket for public access, upload an object into that bucket. add the bucket has an additional secondary origin to the distribution, and then we're going to secure the bucket with what's called an OAI, which is an origin access identity. Sorry, my son is harassing me. Origin access identity, which is actually what it's going to do is it's going to make it so that S3 will only accept connections from CloudFront. So even though the bucket's still public, it's only going to accept connections from CloudFront. Then you're going to test access to S3, which should fail because you no longer have access to the S3 bucket, and they're going to test access using the CloudFront distribution. So if we go look at the labs for this and open this up, what we should see is the same thing. CloudFront, S3, configure the S3 bucket for public access, upload an object and test that you actually have access to the bucket. Then you're going to add the bucket as an origin to your already existing CloudFormation setup, secure the bucket, test that the access should fail. You need to see an error message here, and then you're going to test it using CloudFront, and you should see it succeed, right? And then there's actually a task 9, which is going to have you replicate the bucket across regions. That's kind of fun. So you can do that as well. Let's see. Do note that this is considered to be about a 45-minute lab. So you're going to have about 45 minutes to pull it off. So let's get cracking. I would say if you finish early, please take a break. I'm going to check back in at 3 o'clock. So that's about 49 minutes from now. Okay. And then we're going to do backup and recovery, close the class, and then we're going to focus on our capstone lab. Okay. Let's do it. I'm going to be right here. So let me know if you need anything. I'll let you know if I step away for whatever reason. So just out of curiosity, does anyone work with any kind of backup and recovery components? DR sites, co-location, tape, offsite backup storage like Iron Mountain? Anybody working with that? Yeah. Kind of interesting. Seems relatively specialized, right? All right. So one, DR planning. That's one of the first things, that are one of the business drivers, right? How do we do backups for cloud native workloads? How do we plan for disaster prevention for DR? And then how do we create a disaster recovery site? Like how do we make things highly available but at a DR level, right? Our objectives is like, what do we do for potential data loss? How do we like do data recovery, downtime, service recovery, right? And availability. And what are some best options in cloud for managing backup plans? So 3 different pieces here. 1, just around general disaster planning. 2, about AWS backup specifically. And then 3, some recovery strategies that can be used, right? The question that we're trying to answer for this first one is, what's our recovery time objective? Not our point objective, but how long does it take for us, right, to minimize downtime and data loss? So Warner Vogels is still quoted as saying things like everything fails all the time. How do we mitigate this risk? So really the question here is, DR is really about preparing and recovering from any event that has any negative impact against a business's continuity or its finances. So either its service availability, finances, or both. This is a number of different failures, right? So usually what happens is that, testing, identifying resources, right? Having outdated plans, like these are all factors that really kind of wreck a DR plan, is that you don't test, you don't have sufficient resources to actually recover, and you don't actually have any plans or processes for how this happens. Obviously, the automated, the better. So as far as like being fault tolerant, right? Which, by the way, fault tolerant is often confused with high availability, but this is like built-in redundancy in applications component to ensure there's no service interruption, right? High availability is trying to make things highly available, right, to protect against failure, preferably at a lower cost. So this is, component level versus like kind of more systemic level high availability, right? In other words, fault tolerance might exist like within a single like EC2 instance, like we have 3 EBS hard drives attached to it, right? Versus high availability would be, hey, we've got 2 EC2 instances running because that's high availability, and within those systems they're fault tolerant because there's 3 actual disks even though it only looks like 1, right? Backup is essential because we need to be able to withstand data loss, and so if we're not taking backups, and that, by the way, backups can sometimes be real-time replication of data. But I just want to point out one thing is that even if you are live replicating your data, if you're not taking snapshots, you're not going to protect against corruption. So if someone accidentally deletes something in the data set and you want to restore it and you don't have a backup, well, you've got that error replicated, but you don't have a backup to restore from. So it's not just about necessarily replication per se, but backups are necessary in order to be able to take point-in-time recovery snapshots to restore at different points in time. And then disaster recovery is really about the whole kit and caboodle, how to restore services when a major disaster tries to disrupt business continuity. Now, AWS has multiple regions around the globe to host these major services. There's a reason for that. This is why things like global replication and whatnot exist, is so that you can actually take leverage of these scale points that will allow you to create high availability across different regions. So there's a strict region isolation policy, and with the exception of like large scale events like DNS, typically you don't see a whole region go down. Now I say stuff like that. I think US West 1 and US West 2 are both down right now. I gotta tell you, this is an unprecedented month for AWS because we haven't seen this in a while, right? It might be back up already. I just saw a little tweet on it, right? So planning for zone failover, planning for regional failover, right? It just depends on what your business policy is on this. So whatever your business needs are, that's as far as like continuity, that's what you're going to follow. Now, RPO, which is basically how much data can you stand to lose, right? Versus RTO, which is how long is it going to take for you to restore a business process back to service level, which, by the way, includes the data restoration process, right? So, here an example, the business can recover from losing the last 12 hours of data, but the application can only be available for a maximum of 1 hour. These are all technically defined objectives that are done in the context of the business. Now, obviously, the closer you get to real-time like minimization of data loss and real-time minimization of downtime, the more expensive this whole thing gets, right? People come to me and say like, we can't lose any data. We have to recover our service, within 5 minutes or something like that. And I'll be like, okay, that's $2 million. And they're like, oh, on second thought, you know what? Maybe we could be down for an hour. Okay, that's a different thing, right? Now, if you're going to deal with recovery time objectives and RPOs, and you're going to figure out like how long it's going to take for you to restore from a service, remember that you might have different RTOs and RPOs depending on the level of failure. If an entire data center gets hit by a meteorite, that might have a different RTO and RPO versus like just general normal outages, right? Like a component fails or a zone fails. Typically, though, it's just true for that application no matter what. Mission critical applications tend to go real time. There are some applications that if they're down, you could take days to restore them and nobody cares as long as there's a minimal amount of data loss. Now the services for this, basically it's anything that you need to restore plus the tools needed to do the capture and restoration. From a storage perspective, it might be everything from S3, Glacier, like S3 replication, EBS snapshots, Snowball or data sync tools in order to like replicate data. It could be things like capturing your golden images for your either containers or for your virtual machines. And how do you replicate those the world over? By the way, if you use an automated process to create them, you can just recreate them in another site, however long it takes. So one thing to also know is that whatever process you're using to build your applications and its underlying infrastructure, that should be replicated at least in one other region, just in case there's an issue. Also, you can design things like using global accelerator, ELBs. Obviously, if you're provisioning your entire networking using infrastructure as code, you should be able to make another copy of that entire network over in another region. This is one of the reasons why infrastructure as code is king now, because not only can you just do that for testing purposes, you can do that for recovery purposes as well. And Route 53 is a global service. Obviously, it's gotten a lot of scrutiny lately. If you're worried about that, get another DNS provider to point to your AWS resources. And in a lot of cases, by the way, if it was mission critical, we would have 2 DNS providers, right? Dyn, oh my gosh, DYN, Dyn was one of the ones we would use, right? And AWS. I think that was the last one we were using. My point being is that if it's mission critical, just to say this, I know that AWS offers 100% SLA on their Route 53 service. There's nothing wrong with you looking at somebody else for something that's a global service that AWS doesn't necessarily itself have redundancy for. I'm not trying to knock AWS. They do a fabulous job. This was obviously an aberration, this last outage, but this kind of thing can happen. If all of a sudden you can switch your URLs over to another provider, it's kind of nice, right? Other things to note, like almost every database service, by the way, has a backup tool associated with it, and almost all of them support multi-AZ deployments. If it's DynamoDB, by the way, it's already multi-AZ. So know the service that you're using. Does it already have built-in redundancy and high availability, or do you need to create it? Do you need to create read replicas for RDS because you need to go outside of a region? Those are all questions to ask, all based on what the business needs. Using infrastructure as code like CloudFormation, Terraform, scripts. I gotta tell you, scripts are awesome. I love scripts. I'll write scripts all day long. Not the best way to provision your infrastructure. There are better ways, right? I know I love Bash. I know I've been using it for 30 years now, right? Love Bash like the back of my hand. Some people love PowerShell. I get it, right? Not the best way to maintain infrastructure. There are better tools out there. So just know that even if you are using scripts or using CloudFormation, put it in a repo, replicate it, put it offsite, put it in backups, do something with it, and then practice the failure. You are only going to be as good as your training. So if you expect to recover from some kind of outage, you're only going to do that as well as you've practiced it. If you've never practiced it, then you're going to be horrible about it, and that's totally fine. Just make sure the business knows that you're not going to be good about it because you haven't had any practice at it. So it's never a matter of like, do you have the skills or are you talented? The only question is, have you practiced it? Are you trained or are you untrained? That's it. So when it comes to using the right services and knowing how this functions, testing, preparing, planning, and training are probably actually the 4 most important pieces. Like, I've never met anybody, by the way, who couldn't master a subject if they had enough exposure and training. That's all that's required, really. And people talk about, joke about, hey, it's not a rocket scientist. I just read an article that said that rocket scientists aren't necessarily smarter than other people. They just happen to know the subject, right? I have to say, though, that I've seen some math that really kind of melted my brain. Anyway, so that's disaster planning, right? Just think about what the business needs. How do you translate that into technical requirements? How do you do the analysis against all of your components? Where are your data weak points? Where are your service weak points? How are you going to shore those up? And then how are you going to replicate the whole thing? I've had infrastructures, by the way, that we could stand back up in 45 minutes. And how do I know? Because we actually had to do it from scratch. The whole thing gets stood up in 45 seconds. The application gets restored. Data gets restored. We're good to go. So that's the kind of training and practice and kind of games you want to get to. Now, let's talk about beyond DR. Let's talk about backup. So backup is a fully managed backup service. It's called AWS Backup. And it basically enables you to automate the backup of data across all of your AWS services. So it's going to support obligations, regulations, business continuity goals. It does work with AWS organizations. So you can deploy like data protection policies, backup policies, governance policies. It will force snapshot your EBS volumes, your S3 buckets. It will, by the way, will grab all of these services that you see here. So EBS volumes, file server, EFS, storage gateway, DynamoDB, RDS. It actually does more now. I feel like some things are missing there. So if you put storage gateway, so notice that storage gateway is in the lower right hand side. If you can actually put storage gateway in here, so you can actually make it so that you're backing your native backups into storage gateway, and AWS backups will gather what's being pushed into storage gateway as part of the backup policy. So everything that's listed here, you can actually set up a backup plan. It will execute the backup and put it into a vault for you. And retention and all that can be controlled. So it's the number of times or the amount of retention. You can set all that as you see fit. You know, one of the most common challenges is the complexity of backups. Like, you know, how do I figure out what to back up, right? Compliance, because you don't have a backup plan that includes automation, right? So you got to do it manually, and that kind of thing gets difficult. And also cost, because you're retaining too much or not enough, depending on what you're trying to accomplish. And AWS backup really kind of helps you solve that by setting up the policies, the automation that you need to take the backups, so you keep it cost effective. So cloud native meets compliance. Definitely, you know, there's no added cost for the orchestration, right? It does allow you, by the way, to back up in other regions. This, by the way, can be HIPAA eligible, ISO 27001, 9001, 27017, like all the standard ISO compliances, right? Regulatory compliances. You'll have to read the docs, but for the most part, it's going to adhere to most of your standard audit standards for compliance. So how does it work, right? You create backup plans that orchestrate backup operations on a per policy basis, and you can bring in other integrations as you need to, right? If you're doing cross-account backups, it actually goes into a backup vault, which is then governed by organizations. A backup vault is basically a container in which you organize all of your backups, right? You can actually control access to your backups by sticking them in a vault, encrypting it, and then granting access to different people or users or services by granting access to the backup vault, right? So again, if you use this with organizations, this will allow you to enforce and complete a robust backup strategy that will run across all of your accounts and centralize manage everything. So how do you do this? Just create a backup plan, right? So define the frequency, define the permissions, define the timing and the movement period. What is the retention policy, right? Assign resources to the backup plan. You can either use tags or explicitly call out ARNs, which are Amazon resource names. And then you just manage and monitor the backups to make sure you're catching the right thing. Now, one thing I will mention here that I feel is missing, backups don't matter, restores matter. So step 5 is that you should test your restores, because a restore presupposes that you've taken a backup. So the next time someone says that this is done just because you took a backup, that does not matter at all. Do a restore. If you are not restoring on a regular basis, you have no idea whether or not those backups work. So there really should be a step like 4 or 5 here, which is test and restore your backups on at least a monthly basis, maybe more, right? Just to see if it's there. How would you know otherwise? What if you're capturing the wrong data? What if it's having a problem and you don't even know it? So you can, by the way, automate that whole thing where you do a test restore, test and look for certain data with a certain timestamp, and then delete the restoration once you're done. That way you would get notified if there was a problem. So just a little personal Forrester note. Restores matter, backups don't matter. So test your restores. Any general questions about what backup is supposed to accomplish? I love this statement. I know the goal is 0 downtime, but I'm worried this is going to cost us money over time. Yes, it is. So it depends on what level of restoration you want. So let's talk about the kind of 4 major scenarios that Amazon's going to ask you questions about in the exam. First, they're going to ask you about the 4 scenarios, and the first one is the cheapest, but it's the one that's going to take the longest to restore service, is backup and restore. Now, the way this works is that you back up into S3, and then when something goes wrong, you restore, and you restore all the services, right? So backup and restore is basically you're just backing up the data to a remote location. If a failure happens, you're basically standing up all the infrastructure, restoring the data, and so it's going to take you as long as to restore it. But it's also pretty cheap because you're not really paying for running resources. You're only paying to host your backups. Now, obviously, if you don't have your restore processes tested, this is going to be a disaster. This could take a long time to actually restore, especially if you're doing it manually. That's backup and restore. Now, if it's Pilot Light, the Pilot Light approach actually has you replicating a database from on-premise into into the cloud, for example. So this could use data sync, it could use DMS, which you could be continually migrating your data store, right? And so, Kyle, to answer your question, by the way, yeah, backup and restore is a completely cold site restore process. That's it. But this is what they call it. Pilot Light is equivalent to kind of a warm, like, not a warm standby, but it's a Pilot Light. It's even colder than warm, right? It's just all you're doing is replicating the data, right? So, oh, I see what you're saying. No, you're asking if this is the equivalent of a cold site. Probably, actually. Yeah, now that I think about that, because this one doesn't even have a site. This is 0 site from my perspective. I mean, you have the backup somewhere. But really, the Pilot Light is probably the equivalent of a cold site. Sorry to clarify what I was saying earlier. Because this is less than warm. The only infrastructure that's here that's in the database, it's in secondary mode, right? This is inexpensive to implement because that database is doing nothing. So that cost is the only thing you're going to incur. You've probably got resources sitting here just completely shut down, not doing anything. You might not even have resources here. May not even be running. That's typically not what you do. You typically have resources there that are just shut off. And then what happens is that when you want to switch over, production fails, you then move everything over, like from a DNS perspective, turn the database up, turn the servers up. It'll probably take you minutes to get everything turned up, maybe like 5 to 10 minutes at most if you've already got resources there. The only catch here is that, remember, any changes you make on the left, they got to be replicated over on the right. Data is going to take care of itself, but I'm talking about the web server and app server changes. That's a Pilot Light, right? That's the kind of the lowest of the kind of like warm setups. Now you can have kind of what they call a warm standby. It's an elevated version of a Pilot Light. In this particular case, you actually there's a scaled down but fully functional copy, but it's at low capacity in the cloud. And you might have some kind of weighted DNS that sends 10% of your traffic to the recovery site and 90% of the traffic to your production site. And this is pretty cool because data replication is still happening, but this is a low capacity standby, so it's not going to handle the full load until something fails. And then what's going to happen is you're going to switch this up to full capacity. You're going to switch this up to full capacity. And so your low capacity standby is all of a sudden going to switch to a high capacity because you're going to add more servers, you're going to upsize your database, so on and so forth. So the recovery time objective is just as long as it takes to fail over and for as long as it takes for you to scale up. And then last is the active or just the hot standby. And what this means is it's not even really standby, quite frankly. It's active, which means that both sites are hot, both are at full capacity. It could be 50-50, it could be whatever weighting you want to use. This, by the way, is constantly replicating. Now, I just want to mention this is that your web servers and app servers in the cloud are probably going to have to be talking to the primary in your on-premise site. This, by the way, assumes an RDBMS. If this is like MongoDB or Cassandra or something like that, you could actually talk bidirectionally to both of the primaries in each of the cloud and on-premise locations. So a lot of this changes depending on what kind of data like replication service you're using, right? So this is similar to a low capacity standby, except it's super active, right? And it's at full capacity. Here, failover again. Gonna turn the secondary up to a primary, maybe do some automatic redirection on DNS if that's what's necessary. And then this is gonna then make the full capacity active site now the active site. But I do want to point out is that you're probably gonna have to do some scaling still, because if you were putting traffic between them at 50-50, all of a sudden that 50% traffic is gonna come over to the other side. So you might need to scale. But hopefully you've already got automatic scaling in place, so that doesn't really matter. So backup and restore, pilot light, warm standby, multi-site active. Now, Amazon, I think this is now called the Data Center Migration Service, but they bought a company called Cloud Endure basically, and what it does is you can put it on your source machines, and block by block, it will replicate the data that's on your source machines into machines that are actually in AWS. If you haven't seen the database migration service, which we talked about, or the server migration service, or the data center migration service, which is what this is, it's also called Cloud Endure. That was the original company. This, by the way, again, block by block copies, tons of fun. And you can copy into low capacity machines, and then it'll automatically upsize them if you trigger a failover, right? So it will, by the way, modify the operating system so it can actually run in AWS. So it'll actually add in all the drivers, like it has a machine converter that does this. So it's pretty cool. They used to direct you to the docs at cloudendure.com. I think this is all integrated with AWS now. So yeah. And by the way, you can have a blueprint, like I want Windows to run in Windows. So how does that get converted? Cloud Endure is a pretty cool service. Block by block replication into your targeted AWS environment. Good stuff. So here's some things to think about if you're using backup and restore, pilot light, warm standby, or hot multi-site standby, is that, and this is something you're going to want to be very clear about when you take the exam, okay? If your RTO or RPO, if either one of them is hours, they're both hours, then you can get away with backup and restore. If one of them is real time, meaning you can't withstand the loss of a service or you can't lose any data, then if any one of those is real time, then you have to use a hot multi-site standby. If any one of them is either like minutes of downtime or minutes of data loss, then you're going to use a warm standby. So if it's that or above, you're fine. If it's tens of minutes, like 10 minutes or above, then you can either use pilot light, right? And if you can withstand data loss or you can stand service outage of hours, then it's going to be backup and restore. So if the question reads something like this, you can withstand data loss of a couple hours, but you can't have any service disruption at all, then you have to use hot multi-site standby. So my point being is that whichever of the RTOs or RPOs is the lowest, that's going to determine which of these four scenarios you can use. Now, as you can imagine, hot multi-site standby is the most expensive one, because typically you're duplicating the environment at not full capacity. So cost may also be the factor. What's the cheapest one that will allow you to recover both RTO and RPO within 10 minutes? Well, that's going to be pilot light, right? So those are the kind of questions they're going to ask you about the different scenarios. Any questions about this backup or just disaster recovery in general? Okay, let's do a little knowledge check. Which DR model offers an RTO in minutes at the lowest cost? Now, a recovery time objective of minutes, just going back to this thing, I would think that would be a warm standby, would it not? Just based on what I just said and what we see in the chart. Minutes, not tens of minutes, but minutes. Right? So I would say it's going to be a fully working low capacity standby. Oh, wait, that's a fully working standby. Oh, that is cheap. Can't believe they did that. Fully working low capacity standby. That's not the name of it. Anyway, I would say fully working low capacity standby, but it's probably going to be B, honestly. Names. You know, when someone does wordplay in order to test your knowledge, I got to tell you, I don't like that. I think that's BS. That's just my opinion, right? But whatever. I'm not criticizing AWS. I just wish people wouldn't do that, right? Anyway, Pilot Light's the answer here. Okay. Which metric defines how often data must be backed up? Does the recovery time objective or the recovery point objective, does that define which one, how often data must be backed up? Because we know it's not the other one, right? Oh, don't get me wrong. I'm sure available storage could restrict it, right? And then the other one is that data change rate, right? That also might make a difference, right? If the data doesn't change very often, that might also inform how you back it up. So in this case, it is the recovery point objective, and it is the rate of data change. The data doesn't change but once a week, back it up after the changes, right? Okay, which of the following are highly available resources by default? Meaning which ones are like either regional or global services? That's what they're really wanting you to know. Which one of these are regional or global by default? Well, we know NAT gateways are actually confined to a particular, you know, availability zone, right? Because otherwise we wouldn't need redundant NAT gateways in each AZ in order for them to function. Direct Connect is definitely tied. It's a single wire, right, tied to a VPC. So it's not fully redundant like we want it to be either, right? Now, that leaves Route 53, which we know is highly available, except for the most recent problem. And then ELBs, which are regional, so those are highly available by default as well. Now, notice I didn't say DR like fault tolerant. I said highly available, which means across an entire region. So these would be the right answer for highly available, according to Amazon. Okay. Which of the following are features of AWS backup? What does it do by default? What does it like? What's its function? What was it designed for? All right. So encrypted backups, works across multiple services, continuous data replication. Well, doesn't do continuous data replication, but it is designed for cloud native workloads because it's designed for AWS. So continuous data replication, meaning it's just continuously replicating changed data, would either be Cloud Endure, which is block by block, or you would use like the database migration service or data sync. What method will make an RDS database highly available? Sorry, let's try that again with my boom mic down. Any questions about any of those pieces? Actually, hold on. There was one little piece. Okay. Oh yeah, here it is. All right. So we are going to, and I'm going to make sure that this is listed for everybody. Hold on just 1 second. Let me get this going. Architecting on AWS course supplement. Let's copy this link out. So I'm going to just set you up for this, and then we're going to talk about next steps and whatnot. So this is going to take you into the Architecting on AWS online course supplement, which was in one of our previous like student guide references, right? And what this is that this is going to start the supplement where you basically get the whole class again in this kind of digital format. Now, if you close out the course supplement, the little arrow on the left-hand side, wow, are you just now, by the way, seeing my screen? Seems like it took a while for that to update for some reason. The second piece of this online course supplement is the capstone lab, right? This contains all the instructions about how to run this lab, including things like the lab overview, right? What this lab is all about, the architectural diagram, which is going to be the same one that we saw at the beginning, the different lab tasks that you're going to accomplish, right? And then you're going to continue on to task 1, task 2, task 3, etc. If you need the answers for the lab hints or you want the lab instructions, they are at the very bottom of the whole thing, and they will literally let you navigate step by step through all of the different pieces. How to create an RDS database, how to create an Elasticache, cluster, all of this, all of these instructions are included right in here, okay? So if you want the solutions, just know they're down here. Otherwise, what they want you to do is they want you to run through this capstone lab at your own pace, own decision, and they want you to try and solve the tasks that they're listing up here as far as like creating an RDS database, doing Elasticache for Memcache. Because for example, if we look at the create an RDS database, they're going to give you a story and they want you to create an Aura DB instance in the subnet group, and they're going to, basically tell you that it needs to be this size, it's got to be deployed into this, it's got to be configured with subnets. Okay? Again, if you're like, that's too much, Michael, because I don't know how to do this, or you run into issues, you just scroll down into the lab instructions. You can then scroll down to the section on databases, and it will give you the explicit instructions for how to navigate this. Okay? So the challenges are up above, the full instructions are down below. The full instructions are all under lab instructions under this supplement. Okay? So let's just take a quick little stroll here for a second, just to review kind of what we did. So for this weekend, we started out with architecting fundamentals and talked about the well-architected framework. Sorry, this week, so earlier. Then we had a discussion about IAM, roles, users, and groups, and we talked about account security, and that includes organizations and single sign-on. And then in networking, we talked about internet gateways, VPCs, how to craft subnets, both public and private. Talked about routing tables. We talked about the 2 different firewalls, NACLs, and security groups. We then talked about compute, and we spent a lot of time talking about EC2, AMIs, the different licensing types, which included dedicated instances, which is the most expensive, on-demand, which is the second most expensive, and then spot, which was the cheapest if you could withstand 2 minutes, the 2-minute warning for interruption. And then we had reserved instances and compute savings plans. Then we talked a little bit about EBS in that compute section, And then we talked about it a little bit more in depth in storage. And we talked about instant storage, which we asked you not to use unless you really knew what you were doing, versus EBS, which both had solid state drives and hard drives. And then we went into S3 and talked about the 6 classes of storage inside of S3. And then we talked about EFS as a file share, and FSX for Windows has another file share type. Then yesterday we also talked about DynamoDB and RDS as 2 of the database services, including the database migration service. And I mentioned that there was Elasticache, MongoDB, Cassandra. There's all kinds of database services out there that AWS has, but the 2 flagship ones are RDS and DynamoDB. And then for monitoring and scaling, we talked about CloudWatch, CloudTrail, VPC logs, right? We talked about how you can use CloudWatch logs to capture logs from any source. We even mentioned the CloudWatch agent at that point in time. And then we talked about load balancers, and we talked about auto-scaling. And then we switched gears to talk about Systems Manager and CloudFormation, as Systems Manager was used to manage running systems, and CloudFormation was a provisioner to stand up cloud resources. And then we switched gears to talk about containers, talked about how they're just process isolation, and how you need a container registry, which is called ECR in AWS, to work with the Elastic Container Service and the Elastic Kubernetes Service. And that both of those services had a serverless mode and they had an EC2 mode. And then we talked today about ways of connecting your hybrid networks into, your on-premise network into core. That was where VPN and Direct Connect came up. And then we had some discussions about protecting those networks with, edge services such as WAF and certain, Shield, and using the firewall manager. And then we talked about Lambda, including all of the associated services with Lambda, such as API Gateway, SNS, SQS, and using the step functions service to kind of walk through orchestrating your own workflows with Lambda. And then the last thing we just covered was backup and recovery, where we talked about AWS backup, and we talked about all the different scenarios that we could use to create disaster recovery with AWS. That was 3 days worth of work right there. So before I shift gears and post the evaluation and we move on into the capstone lab, does anyone have any questions? So Mark, I think you have supplemental course access indefinitely. It might be until February 2nd. This is a brand new thing, so no one told me how long. I know that you have it at least until February 2nd, but I think you might have it just indefinitely. I actually had a buddy search for this the other day who's never taken the architecting class, and he could see it. So, I think it's just a supplement anybody can read if they want to. Lab 7, by the way, is definitely going to be available until February 2nd. Just a word of caution, though. Quick Labs sometimes seems to cap the labs at 2 or 3 times, although some people have reported running it 5 or 6 times. Why they were running it 5 or 6 times, I have no idea. But just know that you're probably not going to get beyond 3 times, but I could be wrong about that. It's a pandemic. AWS might have changed some things. Okay. Here's what's going to happen from here. 1, you're going to get it. You already have an email that gives you access to Tutorials Dojo, so you should already be able to get into this thing, and you should have a license key or a voucher, if you will, that you can submit that will get you access to the Solutions Architect Associates exam, the one that we were looking at earlier today. This one, okay? You also are going to get an email, if you don't already have it, that has the guide in it, the program study guide, and I gave you the generic ramp-up guide as well. So you're going to get that from us, and GoToMeeting is just going to send it to you because that's just what they do. So you're going to get the step-by-step guide. You're going to have the practice exams. You're going to have instructions on how to access the supplemental labs. Sure, I got that, right? In addition, I'm going to email you after this all of that stuff in aggregate is going to be in a zip file, most likely. That's going to allow you to just see the whole thing in one fell swoop. And I'm going to resend the video link to you in case you missed it, so you can have the video playlist, which you're going to have in perpetuity. And I'm going to make sure that you have the learning and step-by-step kind of webinar that we teach. It's about an hour about how to study, just in case you forget. What you're going to do is you're going to wait 3 to 5 business days before you email me because you don't have your certificate of completion and you're missing something, unless you know it's something you should already have. But you're going to get an email with me probably within 24 or 48 hours. Just give me a couple of business days to get everything together. But that's what's going to happen next. I'm also going to, by the way, put a bunch of workshop links in there for the EC2 workshop, the EKS workshop, the ECS workshop, the CDK workshop. So, and just put a couple of workshops in there that I know are going to help you if you want to do them. Okay? And then that's it. Am I forgetting anything? Is there anything that just is itching at the back of your mind that I have not answered for you yet? If so, let me know right now. Good. Okay, here's the last step then. By the way, you can ask me at any time. I'm not going anywhere. Here's the evaluation. Please know that this is actually read by the CEO of the company. So please, if you feel like something needs to change, let us know. Otherwise, just fill it out. Let us know what's going on. Always appreciate feedback, direction, improvements. If you think there's something I may have forgotten that I need to improve upon, all welcome. So otherwise, please fill that out right now if you can. They do like to see them. I think this is a trigger for your certificate of completion, so make sure you fill it out. Otherwise, if you don't have your certificate of completion, they'll probably ask you to fill out an evaluation before you do it. So just FYI. I'm sure there's something else I'm missing, but as far as like everything that's on my checklist, it's all checked off. Okay. So fill that out. If you want to take a short break, go right ahead. I'm actually going to take a break until 4 o'clock in about 13 minutes. I'll be back online at 4. And then I'm just gonna hang out and support you as you work on the capstone lab. So if you choose to do so, if I come back and nobody's here, then I'll just consider it closed for the day and I'll shut down. But by all means, hang out if you want to, and hang out with me and do the lab if you want to. If you do that, I'll hang out with you until 6 o'clock. Okay. Otherwise, if I don't talk to you again, hopefully I'll see you in the next class. All right. Is it not enabled right now? Because I was actually just about to start it, so apologize. You might want to take a break because it's going to take about 15 minutes for it to go. Okay, so I think actually we're going to have to take a break. Kyle, sorry, that was my fault. Yeah, so I would definitely take a 12 or 15-minute break because it's going to be pre-warming right now, and you don't want to sit there and watch it burn. So just take a break and come back at 4. Okay. All right, so the lab's activated, and I just checked and made sure all the labs should be activated at this point in time, so you shouldn't have any restrictions there. But Capstone is active and good to go. Thanks for saying something, Kyle. All right, everyone. I'm out. I'm going to take a break for 12 minutes. I'll be back at 4 o'clock. Again, if I don't see you, hopefully I'll see you in the next class. Anything comes up, email support or email me. I'll be glad to answer any questions, okay? So, catch you in a bit.